All right. Well, I think we're going to get started now. We have a lot to get through today. I'm really excited about this meeting. We have a little bit of a benthic theme today. And so we have kind of our longer meeting. We're going to start with our FHAB updates, as we often do. It'll be kind of the extended updates that we usually have in winter. And then we will move into a bunch of really awesome presentations. So I'm one of your co-chairs, Karen Odkins. I'm over at the Department of Fish and Wildlife. And with me are the other co-chairs, if you'd like to introduce yourselves.
Hi, I'm Jamie. Jamie Smith. I'm from Scorp, and I'm one of the co-hosts of the CCHAB network.
And I'm Sarah Ryan with the Big Valley Band of Pomo Indians and another co-chair of CCHAB. Welcome.
All right. Great. Well, we're going to start with just a couple quick announcements. So we had our small work group meetings for the new work groups. All three of them had a first initial meeting. The Fish and Wildlife group, as well as the drone and aerial surveillance group, were able to find a leader, which is really great. And they have agendas and meetings that are going to go forward. So those are set in the official work groups now. We are still looking, however, for someone to take over the instrumentation work group. So that work group is kind of looking at what different instruments people are using and kind of working on how we can improve them as a community. So if that work group is not able to get somebody to lead it, unfortunately, we do not have the capacity to keep it going by ourselves. We've got a lot on our plates as co-chairs. So please let us know. Feel free to email any of us if you're interested in taking that role on. It's something that I think could be a really great kind of resume builder for someone who hasn't led anything yet. So if you'd like to take a stab at that, please let us know. Anything else that you guys want to add for announcements before we get started and jump into our agenda here?
Okay, good on my end.
Sarah?
Same here.
Okay, great. Okay, well, let's jump right in. We have a lot to get through. So we're going to start with the freshwater harmful algae bloom program updates, starting from state board. But I just want to say we have a lot to get through, and you guys set some really awesome slides, all of the folks from FHAB. So please try to keep it to 4 or 5 minutes tops so that we can get through everybody. I know you have a lot to share from this really exciting year. So Carly, Marissa, do you have slides that you wanted to share?
Yeah, hey, good morning. This is Marissa. Yeah, we have a couple slides if you want to share us the permissions.
I think that's it. Jamie, can you do that?
Yep, you should have permissions now.
All right, thank you. Yeah, it's working. All right. Hi, folks. I'm Marissa Van Dyke with the Water Boards. At the State Water Board, representing the statewide freshwater and estuarine harmful algal bloom this morning. I'm also joined with my colleague Carly Nilsson. We co-manage the program, and also we have many coordinators across the state in all the different regions, and majority of them are also here today to give you regional updates. So I'm going to be quick to let them shine with their material. So just to introduce them, we have coordinators across the state at each of the regions, from the north all the way down to San Diego. We have an update. So majority of the coordinators are borrowed from other programs as resources are available. And then we do have 3 full-time coordinators: Mike Thomas in North Coast, Dana Schultz in Central Valley, and Sabrina Rice in the Lahontan region. All right, and we always like to give a reminder of where you can find all of the California HAB resources that are developed by all the different organizations that participate in CCHAB and also governmental agencies. We present this all on the California HABs portal, and you can get it here at this link, and you can find our maps of current events, and then also materials on how to communicate with the public, the statewide voluntary guidance for response to blooms in recreational waters, and standard operating procedures for field collection. And we just want to highlight one product. Again, we've presented this the last few times, giving people plenty of heads up that we are preparing to publish our final report in April 2025 regarding satellite remote sensing. This report articulates different assessment approaches for freshwater HABs and inland waters across the state. So how to use that data to answer many of the common monitoring questions, status and trends, and also some drivers. So that report's coming out. And with that, we also are building an application, a web app that helps people walk through a lot of those calculations for waters that can be remotely sensed in California. And one of the parts of the report was also to determine how to better improve the quality and the calculations data for event response. So we will be making some updates to the FHAB satellite web tool. Again, this is hosted by SFEI as a joint project with water boards. And here's their link. Just wanted to highlight that the look and feel won't change at all. We are going to be making some modifications to the statistics that you see when you zoom in to an individual water body and look at the satellite imagery over time or at just one time point. We're going to be adding, updating the threshold for event response. We're reducing the number of pixels that are necessary to view a lake. So we'll actually have a few more lakes that can be viewed on our tool. And we'll be sharing a write-up of all the major changes over the listserv. But we wanted to give you a quick snapshot of that. We'll also be making a link so that folks can get to the web app for doing those data assessments a little bit more easily right here on the tool. So if any of this perks your interest, feel free to contact us. This is our general inbox here, cyanohab.reports at waterboards.ca.gov. And we're happy to chat with you. Thank you. I'll hand it off to all the co-chairs.
Yay, that's exciting. Nice. Little
Great,
thing.
thanks, Marissa. Okay, we'll start off as we do with Region 1. Mike, are you here?
Yep. Good morning, everybody.
Oh, and just let me know when you want me to click through slides for you.
Sure, thank you. My name is Mike Thomas. I'm the FHAB program lead for the North Coast region. I guess an update here. Rich Fadness, who I worked with closely, our swamp lead, has officially retired at the start of this year. So we're all wishing him a good retirement. Next slide, please. Routine monitoring that occurred in 2024. You guys have probably seen this. Klamath Basin, they're doing routine monitoring for microcystins, the tribal consortium up there. Big Lagoon also monitoring for microcystins. And then Russian River, we have Sonoma Water doing some biweekly cyanobacteria IDs. Next slide, please. Pre-holiday assessments in 2024. We did 7 water bodies. You can see the results of the Memorial Day through post-holiday assessments. We did have caution and then danger posting on Lake Pillsbury, but most other water bodies, no advisory was issued. Next slide, please. And here's just a summary table of regional postings in 2024. It's broken down by benthic and planktonic, and then we also had a couple of marine blooms. But yeah, definitely toxic algae alerts or benthic cyanobacteria is the main concern in the North Coast region. Next slide, please. And here's just a quick summary of the illness reports. A lot of these were determined not to be FHAB related. Some of these we were able to visually confirm, shown there in green, but a lot of them also needed just additional information that we were unable to obtain. Next slide, please. Other goings on, we participated in the CCHAB benthic subcommittee, co-leading that project, incorporating a lot of our findings in the North Coast region. We also collaborated with US EPA ROAR project for a second year, deploying SPATs in the South Fork Eel River, and then collaborating with University of Nevada at Reno on some of their projects as well. Next slide, please. Here's a list of partner trainings. We did virtual and then 3 field trainings.
On it right now.
Oh, good, good.
Oh. And just a link here is a recording to that training. If you would like to get a hold of our slides, just please email me, let me know. Next slide, please. And then I guess big news in the North Coast region, we had a series of reports come out. We had the benthic cyanobacteria cyanotoxin threshold memo prepared for the benthic subcommittee. We'll be going over that later today. We also got out our tiered report summarizing the 2022 and 2023 special studies. And this goes over implementing and evaluating our tiered approach for using SPATs for early detection. And then our end of year summary for 2024. Next slide, please. And again, yeah, I just want to thank all of our partners. We would not be able to do what we do without you guys. So thank you very much.
So much, Mike. All right. Now we have Christina at Region 2.
Hi, yeah. It's always so hard to go after Region 1. So, hi, yeah, Christina Shida at Region 2. You can keep going. Next slide. I guess kind of bigger news is we lost one of our staff. So I'm down to less than 5% for HABs. So I really appreciate State HABs, Marissa and Carly, for helping out this year and responding to a lot of the emails and whatnot. We were lucky to have some partnerships with nonprofits that helped us to do some of the field work. And just kind of overall, we didn't have as many HABs, or at least notifications to us this year as we have in the past. So, and yeah, sorry, go ahead. So incident responses, we had about 17 incident responses. We had 8 of them were confirmed. We were across all of our counties and, oh, did I update this? Yes, I did. Okay. We had 2 red tide responses, and again, because of limited staffing, I was able to do only 1 site visit this year. All right, and there's a map of the spread, pretty spread across. Here's just a more detailed table of where we had notifications. Again, not as many deaths or illnesses, and not as many confirmed as we have in the past. Most of them ended up being other things like low DO issues from other reasons, or duckweed and whatnot. And this table doesn't include East Bay Regional Parks. That does a big chunk of the sampling in our region. Sorry, you can go ahead and switch to the next one. We did take part in the holiday assessment. Our swamp crew did 3 of the sites, and then we had some partner groups in Napa. So the Napa Eye Care Group and the Sonoma Ecology Center did 2 sites each up in their region, and they didn't end up with any advisories, luckily. Okay, next. We also had partner monitoring again this year in Lake Merritt. This is following the big red tide that we had in the fish kill a few years ago. And so they were out there every month collecting samples and doing weekly DO readings with one of our sondes. And luckily, again, no significant HABs occurred there. Okay, next. And then lastly, we put together, or working with the San Francisco Bay Red Tide Response Group, and there was a big update to that procedure this year with that group. I'm not part of it, so I don't have any more details, but if you're interested in that, you can let me know and I can get you that information. All right, that's all I have.
All right,
Thank you.
Thank you so much. And now we'll hear from East Bay. Anya, are you on?
Yes, I am.
Fabulous.
Are you presenting my slides or do I? Okay,
Yeah,
great.
yeah.
Awesome.
All
Yeah,
right.
well, hello everyone. I'm the limnologist for the East Bay Regional Park District and I'm presenting today. about 2024. Next. So this is just a overview over 8 water bodies in our park district, and not all of those are have body contact for swimming. So some of them are just for boating and fishing. But I just wanted to show this because it shows that all our lakes pretty much had danger and closure advisories in 2024, some more, some less, but the worst out of them was Contra Loma and Lake Chabot. Next. So we're particularly working on I'm working on Lake Temescal and Lake Anza. And Lake Temescal and Lake Anza, they were both greatly impacted by HAPs in 2024. Lake Temescal inherited a danger posting from 2023, and we pretty much had overwintering microcystis, which then caused a toxic bloom by late March. And it stayed pretty much, the toxic bloom stayed till July 18th. And so the lake was only open for swimming for about 105 days out of the swim season, the 213 days that account for the swim season. So it was less than half of the time, which was a bummer. We were able to open after July, and then it remained open for the season, for the rest of the season. We did a couple treatments at Lake Temescal last year, Utrosorb G and Utrosorb water column, WC, in early spring, but the outcome was not as desired. And we were thinking or after discussion with some consultants, we think it was the alkalinity of the water that had the clay settle out faster, but also the dose was insufficient. But that's a money issue, right? Because these treatments are quite expensive. Also, we tried dye for the first time in our lake between April and August 13th. We did every 4 weeks. And I'm not so sure about the impact of the dye as well, because the bloom literally occurred at the same time. So we have to consider whether we're going to do this again next year. Next. So what's next for Temescal? We're planning to install an oxygenation saturation technology system in Lake Temescal, and we're currently working on the permits, but we hope to get it in spring, and that should dramatically help with the anoxia that we see in the lake during the spring and summer months. And next. Lake Anza, I don't know if you remember, but we had huge issues with Azolla, covering the entire lake in previous years. This year we managed it really well, and I'm not sure if it was the treatment that I did early last year, but it was not minimal Azolla and duckweed, and it never established after we removed it manually and did a treatment. Lake Anza was most impacted by HAPs in 2025. As you can see, this was only open 77 days out of 213 in the swim season, which was a bummer. And what's next for Lake Anza? So we have permission now to treat Lake Anza with the phosphorus remediation treatment, and it will be the first time in the history of the lake. So we're gonna attempt that in March or April. And next. We also collected fish tissue samples again, which we do every year. And sorry, I got distracted by the chat. And we did not find any microcystins detections in the fillets, which we haven't really any of them in all the years that we've been sampling. But 18 out of the 28 liver samples had microcystin detections, and the highest one was 134 in Lake Temescal. So that was my update. Thank you very much.
Thank you, Anya. And feel free to, it looks like there's questions in the chat, so feel free to answer those there. All right, and now we're on Region 3. Melissa, who is the coordinator, is in the field today, but I think either Marissa or Carly will be speaking on their behalf.
Great, here's Marissa. Yeah, I just want to step in for Melissa Daughtry. She's also the ambient water monitoring coordinator for the region as well. So we appreciate that she's in the field, but we wish she could have joined us. She wanted to highlight their work on the holiday assessments that were coordinated at 3 time points during the calendar year last year. And these are some of the, this was targeted at some of the priority recreational lakes and reservoirs in their area along the Central Coast. So they started in Memorial Day and ended with the Labor Day assessment, and didn't continue, until the October period. So from their monitoring, Lake San Antonio did have some postings. Caution sign was the highest advisory posting last year, including a severe fish kill in July that impacted entire lake. And this was reported to the illness work group, and we worked collaboratively with those partners in the illness work group to investigate it. And we did report that to CDC's OHABS database as a HAB-related report. Lake Nacimiento also had some monitoring, and the monitoring didn't trigger a posting, just some educational information through the general awareness signs. And that's repeated again for Santa Margarita Lake. Laguna Lake did not have any advisories based off the monitoring. And then the last two, Lopez and Oso Flaco lakes, did have some advisory postings up to the caution level. And uniquely, saxitoxin was detected at Oso Flaco, which also has connection to the coastal waters as well. All right. Is there another slide?
That's all. Thanks, Marissa.
Okay, I believe that was it. Okay, thank you. And that's the update for Central Coast.
All right. On to Region 4. Emily, I think I saw you sign on.
Yeah, hi, good morning. So I don't have slides. When I turn it over to Jamie, she has a few slides.
Okay.
Oh, she did make a slide. Wait. She has a
You're the
special study
Jamie
slide.
slide.
Yeah, I'll
Okay,
turn it
great.
over for the special studies, but just like a verbal overall. We don't have like 100% dedicated HABs person, so I just handle notifications and submissions when they come through, with a lot of support from Marissa and Carly, which is greatly appreciated. They helped me coordinate some pre-holiday assessments with LA County Parks and with one LA City water body. And so we're hoping to continue that in the next season as well. We also have like the regularly sampled water bodies, Pyramid Lake and Castaic, and Pyramid and Castaic generally have some blooms every year. So anyhow, that's kind of a higher level overview of the regional monitoring or incident reporting that we get. And then we also funded a study with SQUIRP. And so Jamie Smith will provide an overview on our coastal HABs project. So thank you, Jamie.
You're so welcome. Yeah, so one of the Region 4 special studies this year was looking at the presence of both marine, so we're calling that here algal toxins, and freshwater toxins in the coastal zone. And so the goal of the study was to just look at the co-occurrence of those toxins, and also just understand the prevalence of when we see freshwater toxins in the coastal kind of marine environment. And so just the high level, summary of the approach was that this was a part of a broader study through the BITE Regional Monitoring Program. So that program does monitoring basically through the BITE region, so Santa Barbara, all the way down to San Diego. And that program had a similar type study where they visited a total of more than 30 sites throughout that Santa Barbara to San Diego region. And what we did with Region 4 was do an enhancement where we visited 7 kind of freshwater impacted systems monthly, in addition, and kind of put that in the context of the BITE study where coastal sites were visited 3 times throughout 2024. So the field work for that study, both the BITE Regional Monitoring Program and the Region 4 project, just wrapped up just a few weeks ago. So you can go to the next slide. Just some additional detail on the approach here. So this is kind of a zoom in on the coastal area of Region 4. And so the red circles are the locations where we did intensification. You can see a couple other sites like Zuma Lagoon and Channel Islands Harbor. Those were additional bite sites. So then again, those were the ones that were sampled 3 times in 2024. And then the ones with the red circles were sampled monthly. We sampled shellfish for the quantification of microcystins and domoic acid. Also collected water samples and deployed and retrieved passive samplers. We did some eDNA sample collection and then some other water quality parameters to kind of get a sense of who are the algae there and what are the kind of corresponding water quality parameters. So go to the next slide. And so just a preview, because again, we just wrapped up the field work like 3 or 4 weeks ago, just at the end of 2024. We have some shellfish data that I'm showing you here from those Region 4 sites. And so we're already seeing, we're working on getting additional months in, but here's January through March 2024. On the left-hand side, we have microcystins, and on the right, we have domoic acid. And so what you're seeing here is there's some coastal sites like Alamitos Bay and Los Angeles River, Marina del Rey, where we're seeing microcystins present in kind of the shellfish beds in those zones that have kind of a freshwater influence. And in some cases, we're seeing the co-occurrence of the marine toxin domoic acid at the same time. So this is hot off the press. We'll have more information and probably, I think there'll be interest to kind of share the broader results with the group in a couple months when we have more data. So I think that wraps that up. Karen, if you want to move on to the next group.
Thanks so much. Very interesting. All right, Region 5, Dina.
Hi, good morning. You can go ahead to the next slide.
Right.
I'm Dana Schultz, the FHAB program coordinator for the Central Valley Water Board. So in the map to the right, where that light blue area that spans from Modoc County in the north through the Central Valley to Kern County in the south. A recap of our event response this past summer. So we received 65 bloom reports across 17 counties. A majority of those were made by the public through our online bloom report form. Of those 65 reports, 34 were investigated by the Interagency HAB Illness Work Group, and 20 reports were determined to be HAB related. The reports that were HAB related spanned 5 water bodies. Those were Clear Lake, Copsey Creek, Cache Creek, Brookside Lake, and Discovery Bay, and included 11 fish kills, 1 dog illness, and 8 human illnesses. Next slide. I wanted to highlight 2 of our event response efforts. So first, Discovery Bay, we received a number of reports throughout the month of June and were able to mobilize for some sampling in response to that. The sampling was a joint effort between OWEMA FHAB and Region 5. Our office and OWEMA FHAB handled the first sampling event. The microcystin results are plotted to the right. So just briefly, in the late June sampling, we saw scums in that lower southwest region of Discovery Bay. So Lighthouse Bay scums measured 269 micrograms per liter microcystin. And then towards the end of the summer, in our late August sampling, we saw scums more out towards Willow Lake in the marina, and the highest detected scum microcystin during our sampling came in at over 5,000 micrograms per liter microcystin. Next. Another event response effort this summer was our work along Cache Creek. So you can see in the map to the upper right, that's the Cache Creek watershed. Cache Creek is fed by Clear Lake and Indian Valley Reservoir. We went out in response to a few bloom reports that came in through our bloom report forum. Cache Creek spans Lake County and Yolo County. The work where we went out and sampled was in Yolo County. When we went out late August, the water did look quite green, and results from that event. When we sampled the flowing water, the highest microcystin we got was about 5 micrograms per liter, which warranted a caution advisory. That's the lowest tier 1 recommended advisory. But interestingly, what we found is along the banks, often there was a lot of green algae or other sorts of algae and growth, and we saw the cyanobacteria kind of accumulating within that growth. And when we scooped up that water, the highest measured microcystin concentration was just over 100 micrograms per liter. Next. Okay, so moving on to highlight some of the monitoring programs in our region, I wanted to start with our partnership with Restore the Delta. So this program, led by Spencer Fern, has been sampling the Delta near Stockton for about 3 years now. This summer, they sampled 7 sites from May through September. They sent samples in monthly for ELISA testing, and they did weekly screening with microcystin test strips. That lab ELISA microcystin data set is funded by, this summer was funded by Water Rights. And for the most part, there was no toxin detects this summer. There was just 2 microcystin detects, a very low level at Smith Creek early in the season, and a level that warranted that low caution advisory at San Joaquin River near Windmill Cove. Next. And then next, I wanted to highlight another partnership with Tulare County. They were able to go out and do comprehensive sampling of 4 sites. You can see in the map to the right along Lake Cahuilla and Cahuilla River. Next. And they collected water grabs, deployed spat, and were ready to collect benthic mat material. I think there might be some data on the next slide. And benthic mat material, if they saw it, and water grabs, there was almost no toxin detects, and no toxin detects that led to any recommended advisory postings. As you might expect, the spat did pick up some toxin, and that's what's plotted to the right, but the levels were relatively low. And Tulare County environmental health staff did see some green algae growth in the middle of the summer, but they never saw cyanobacterial mats. Next. And I wanted to wrap up by saying thanks to all our partners, thanks to those that participated in the holiday assessment efforts, and thank you to those in our region that have monitoring programs that share their data with the FHAB program. We use that data to post advisories to a clip of that website you see to the right, the HAB reports map, where the public can access and see if there's any HAB testing and HAB advisories where they're looking to recreate. So thank you to all the partners. And that's it.
All right, thanks, Dana. Before we get to Sabrina, I don't know, Sarah, did you want to say anything? I know you're presenting later too.
Yeah, I could share my screen and just show some information about this year's.
Go for it.
Okay, thank you. And thanks, Dana, for that information. We're going to follow up with you on one of your slides. So for Clear Lake, so I'm Sarah Ryan, the environmental director for the Big Valley Band of Pomo Indians, and on our website, which is bvrancheria.com, and I will there's a historical data, and I will go ahead and put that in the chat so you can get to the URL. But this report is on that page, and also reports from previous years and cyanotoxin levels. So basically, we were out there starting early in the year. We were actually going once a month to during the summer or the winter months, and twice a month during the summer months. In this report of our 2024 year, first of all, I'm updating just what the highest toxin levels were for all of the years, and you can see the highest toxin level this year was at a place called Lily Cove, which is in a homeowners association on the shoreline, and at 16,000 micrograms per liter. Looking at the summertime months, we have this is based on the recommendations, with danger being at 20 micrograms per liter, warning at 6, and caution at 0.8. We looked at we have a number of sites, including the interior of the lake, which we partner with the county who give us samples. So we are kind of tracking at what how many times these sites are impaired, and it's a combination of public areas, private property, and parks, tribal lands. So there's information about that. We are looking at each arm and noting that in terms of caution, warning, and danger, that it's actually the Oaks Arm that had the most danger toxin levels from our twice a month sampling, and the lowest amount of danger levels was the Upper Arm at 3%. So there's a little more info on that. We also in here, we do a lot of outreach using the recommended signs, and we have a Facebook page as well as on our website. Share this information with the county so they can put up signs, as well as the FHAB program. And we're also looking at, we do microscopy in-house, so we are looking at the kind of how the species, I guess, move from mostly diatoms to then nitrogen fixers to then microcystis, to then other types of things like planktothrix and other non-nitrogen fixing cyanobacteria genera. So just kind of watching that over the years. Information is also shared out. We do have a tap water testing program through a CDC grant, and it's a project that we're working on with Public Health Institute. And we did find we do test the private drinking water systems, which is basically the self-supplied systems for cyanotoxins, and also get information about their treatment. And even as late as November of this year, we did have detects of cyanotoxins in finished drinking water from one of the homes that gets their water directly from the lake. And so this is, when the blooms are mostly past, but, finding it in their tap water, as well as intact cyanobacteria. So that's basically it. I'll be talking about our benthic program a little bit later today. Thank you.
Sarah. All right, Sabrina, you're up. Region 6.
Morning, everyone. I'm Sabrina. So yeah, I'm the coordinator for the Lahontan region. Next slide. I did give this presentation at the last CCHAB meeting, so nothing's really changed. I kind of jumped the gun a little bit on the last meeting and did the summary early, but anyway, so this is just the highest advisory level we had across all the water bodies in our region this past season. Next slide. And here's just kind of a general map showing where those advisories were. They were spread from, throughout the majority of our region as high as Eagle Lake. And then the lower part is the lowest ones were Silverwood Lake and Lake Gregory. Next slide. And then I always just like to show like what the blooms looked like. We had one of the highest toxin concentrations that I've seen in our region this year, which was at Crowley Lake in September, around 20,000 micrograms per liter of microcystin. And then around the same time, we also had Bridgeport, which that was the highest it had reached as well at 2,000 or almost 3,000 micrograms per liter. And then so Crowley Lake, Bridgeport Reservoir, and Diaz Lake were the 3 danger advisories we got this year. And the rest of these only reached caution. Next slide. And then here's just kind of showing, the transitions we've kind of seen over the years. So just how many samples we've taken over the years, that changes year to year depending on, what's going on, how many incidents have been reported to us. And, obviously our program was growing earlier in like the 2018 years. So there wasn't as many sampling done then either, but it also tracks, how many advisories we've had over the years. This year, we were really inundated with a lot of illness reports this year. It seemed like they were coming in every week for a little while there. I did not double check on if these have all been reported to the OHAB's website yet, but we had several reported. So the bottom lines were showing the second to last row, is showing just which ones were reported to us, and then the bottom one was showing which ones had been confirmed to be HAB related by the illness work group. So 3 fish kills, 1 dog death, and 4 human illness cases were confirmed. Next slide. And then the type of monitoring we've done, so assessing new and reoccurring blooms and incident response. Like I said earlier, that was pretty busy with the illness reports this year. Our special studies, we've been monitoring Red Lake since roughly 2019. And we continued that again this year with the help of CDFW. And then we started a benthic stream investigation this year of the Little Truckee River, Big Meadows Creek, and the Upper Truckee River. Luckily, we didn't have any really high toxin concentrations, but we were seeing benthic HABs at all of those locations. And then partner monitoring, we rely pretty heavily on our partners in our region just because it's so long, but for ones that were kind of more established partner monitoring programs, we work with Inyo County to monitor Diaz Lake, Mill Pond, and Pleasant Valley Reservoir, and sometimes Owens River. They go out monthly and do monitoring in those water bodies. And then Los Angeles Department of Water and Power this year kind of did the same, sharing their monitoring data with us monthly. And we were able to put that data on the reports map to share that with the public as well. And then our largest monitoring we did is the pre-holiday assessments. And you could go to the next slide. I think that one summarizes. Yeah. So here's just kind of a summary table of how many water bodies we sampled during each assessment, and then the advisories we recommended for each. We don't do the Memorial Day assessment as much in our region because we typically see blooms later in the season. So we opted to do the post-holiday assessment. But yeah, we are busy for these. Again, I rely a lot on our partners, and thank you all if any of you are on the call. And then next slide. And here's just our partners who help. And that's it.
Thank you, Sabrina. All right. Up next, we have Jeff at Region 7.
Hello. My region hasn't had any reported blooms for quite a while, but we do continue to monitor during the holiday assessments, and we'll continue to do that. My region recently got a new executive officer. He seems to be very motivated to get things done, so I'm pretty optimistic that we're going to get some really good HABs work done over the next few years. Right now, we have two significant projects we're working on. The first one is Lake Havasu, which I've already talked about before, so you guys are kind of familiar with that. The only difference is we're finally getting ready to start. We were supposed to start, I think, in March of last year. But with all the coordination, there's a lot of different agencies working together, and just trying to get everything together has been a real challenge. But we have a start date of February 11th. And we have another agency on board, the Bureau of Rec, and they're going to contribute staff, a second boat, monitoring equipment, all kinds of stuff. So we're really happy about that. We can finally get going. Our second project is Weast Lake. It's just a small lake in an agricultural area. It's about 45 acres. There's a cattle feeding operation adjacent to the property, although I think it's at a lower elevation, but we're still going to look into that. It has an average depth of around 12 feet, but it's a really important recreation destination for the community because we don't have a lot of recreational waters that you can actually swim in. The lake's been experiencing repeated blooms for the last few years. They've had fish kills. They've had to close the lake to swimming. The blooms consist mainly of Raphidiopsis, we found through our testing, and they tend to cover the entire lake throughout the whole water column on the surface. The wind and currents tend to concentrate it at the shore, just like everywhere else. So it's really been a problem. We did a preliminary assessment. I went out with the county health department. We went in a little boat. We collected water and sediment samples, and we found the sediments to be anoxic. We did find elevated levels of phosphorus. So my plan is to conduct a full lake assessment with a focus on internal nutrient loading first. From there, we'll look at the external loading and whatever other factors might be contributing to the blooms. And once we're done, we're going to evaluate that data and not only determine the cause of the blooms, but we're also going to use it to develop mitigation alternatives that we can recommend to the county for implementation to get the lake healthy again. Because we always monitor waters and we say, oh yeah, it's dirty. What do we do? Well, let's look at it some more. And that's what we do. And so this time it's like, no, let's get this lake fixed. Let's get it going. So we are going to coordinate with the county, and hopefully they will be willing to spend the money to implement whatever mitigation measures we recommend based on the assessment. That's pretty much it for my region. Thanks.
Right, thank you. Okay, Kirk, Region 8.
Good morning, everybody. Kirk Larkin with Region 8, the HAB coordinator. Move on to the next slide. Region 8 is located in Southern California, incorporating parts of Riverside, Orange County, and San Bernardino County. I'm going to focus on some of the monitoring assessments that we completed during the 2024 calendar year. I'll have additional details on exact locations, but as you see here, we had pre and post holiday sampling that was completed at Big Bear Lake, Lake Elsinore, Lake Hemet, Mill Creek, and Lytle Creek. Next slide. So for Big Bear Lake, we did complete a pre-memorial holiday sampling, as well as continued on with additional sampling in the post-holiday season. As you can see, the first two sampling events for Memorial Day and 4th of July, there was no advisories. There were low-level detections of microcystins, but they did not exceed the caution advisory notification. However, for the pre-Labor Day holiday sampling, there was a noticeable bloom, but there was also in an area in Boulder Bay on the south portion of the lake, there's a little cove area where a lot of the wind-blown blooms get accumulated. And there was a noticeable scum that was sampled. That scum did come back with a danger advisory from elevated toxin microcystin levels. But overall, the lake, there's two other samples that were collected. Grab samples collected in Boulder Bay, as well as on Stanfield Cutoff, which is on the the east end of the lake. Prevailing winds usually push the blooms from the east or west to the east end, so we get concentrations further on. So those samples did come back as a caution advisory, but as the temperatures cool down, the lake actually the blooms start to die off. So for November, we did a post-holiday, and so there's no advisories at that time frame. Next slide. Lake Elsinore, when you're looking at the advisory notifications, conditions look pretty bad throughout the year, but the city has been actively working on identifying causes of a chronic bloom at the lake. They have some pilot scale treatments that are going on, as well as some active treatment. You can't see it on obviously the information that's shared on the screen, but if you looked at the satellite imagery, you'll notice that the blooms kind of peak throughout the year. There's definitely some ups and downs. With this particular data, we actually went out and conducted pre-Memorial Day, 4th of July, Labor Day, and post-holiday sampling. But the data is actually supplemented with monitoring data that is also shared, collected and shared by the city, Lake Elsinore. So as you notice that the advisories, ran from, caution all the way up to danger level advisories. Microcystins are predominantly what's triggering the advisory notification levels, but they're definitely working on trying to improve the lake water quality, and hopefully we can see some improvements in 2025. Next level. Lake Hemet, similar to Big Bear, there was a scum that was noted along the north shore during the pre-Memorial Day sampling. So we collected an additional sample to characterize that bloom. It did come back with elevated levels of microcystins in the danger level advisory. But we also collected a surface grab sample near the campground boat launch on the east end of the lake, which showed microcystins were present. But on an error of caution, we made sure that we had a lake-wide advisory notification of caution for the pre-Memorial Day holiday. As we sampled through the remainder of the year, you can see that there's caution advisory notifications that persisted throughout the 4th of July, Labor Day, and post-holiday. Some of the advisories are based on visual detections of blooms, whereas the toxin concentrations kind of hovered right around caution advisory threshold, so slightly below it. But again, to err on caution, we recommended that they have a caution level advisory for the lake. Next slide. So Mill Creek, it's a creek up in San Bernardino County. We only collected the pre-4th of July and Labor Day samples, as well as a post-holiday. Blooms typically occur in this lake later on, or in the stream later on in the season. So we elected not to do the pre-Memorial Day sampling. But as you note here in the fall, there was a toxic algal mat that was detected, Microcoleus cyanobacteria. And so we had a caution advisory notification for Mill Creek. Next slide. Lida Creek, San Bernardino County as well. As you notice, there was no advisories for this particular creek throughout the season. And again, kind of erring on the side that blooms typically occur in these locations later on the season. We did a post-holiday assessment in November as well. But again, there's no advisories for Lida Creek. Next slide. And then just kind of a snapshot of some of the advisory notifications we had in response to HAB bloom reports. I've made comments about some of these in previous CCHAB meetings. Just as a summary, we had Mystic Lake that has had a planktonic bloom that's been persistent throughout the year. And then North Fork San Jacinto Creek, there was a toxic algal mat that was detected. I had some coordinated sampling with the San Diego Zoo and Wildlife Alliance in response to, there's a mountain yellow-legged frog habitat area. So we had, like I said, joint site investigations and sampling events that occurred there. Reflection Lake in June or July, planktonic bloom and wildlife death that was reported. It's a small private lake, did have incident response, but samples were not collected for that particular event. But we did issue a caution advisory for that site as well. Lake Evans, Fairmont Lake, there was a benthic bloom, both planktonic and benthic, in addition to reported wildlife death. This particular site, we identified that the cause of the blooms were, or cause of the wildlife death was not HAB related, but we did have caution advisories that were linked to that. And then the last report on here is from Cucamonga-Gowski Regional Park. That was a planktonic bloom that came in response to San Bernardino County Parks Department that were sampling that lake in August. And that's that I have for Region 8.
All right. Thank you so much. And last but not least, we have Region 9.
Hi, I'm Carrie Kowalski, the FHAB leader for San Diego Water Board, and my partner, Debbie Woodward, she's also on the line at the meeting. Next slide. So our activities for 2024 included incident response, the pre-holiday assessments, and a special study. As far as the incident response and satellite notifications, about 5 of them required sampling and some other follow-up actions. For the pre-holiday assessments, we had 5 sites that were funded for the sampling. And one of them I just wanted to point out in particular was Spring Pond with the tribal government with Viejas. So we used this opportunity since they were interested in learning a bit more about the HAB sampling. So we did the pre-Memorial Day sampling together with them and then handed off kits for them to do the other 2 holidays. And then our special study was limited, but we focused on small public lakes and ponds that are typically used for recreation and fishing, and we prioritized our sites within disadvantaged communities. Next slide. The most noteworthy bloom that we had in 2024 that is worth mentioning happened at Lindo Lake, and it was noteworthy because it happened surprisingly early in the season. So in March, we were called out because California Fish and Wildlife, they were actually there to stock Lindo Lake with Sacramento perch. They're using it as a reintroduction, sort of like stock pond and then reintroduction in other water bodies. But unfortunately, the microcystin levels were above 8,000 micrograms per liter, and you can see the bloom just overtook the entire, that was the eastern basin of the lake. And we saw microcystis species, and then Dolichospermum was also present. Next slide. Some other blooms that we had in our region in 2024 also included, so Lindo Lake did the bloom, it got the toxin levels and bloom subsided a little, it got better. So by June, it was down to a caution versus the danger level that you saw on the last slide. And that was part of our special study as well. Libby Lake was also, that lake had caution level in the July timeframe, but eventually subsided later in the year. And then Santee Lake was another lake that we did for our special study, and that unfortunately was at a warning level in July, and then really only subsided down to a caution level after that. Next slide. Heritage Park Pond was another pond from our special study that ended up at a warning level in July. And then 2 reservoirs that were notified via satellite imagery was Marina and Diamond Valley Lake were both at a caution level. Diamond Valley Lake had subsided, but now it's back up to a caution level. They're experiencing the start of a bloom again, unfortunately. Next slide. And this is just a little summary of the special study that we worked on. So the smaller ponds used for fishing and some recreation. We had 14 sites, and it was mostly good news. Only 3 came out to be toxic during our sampling events, which we focused on during the bloom season. And then again, just to highlight our coordination with Viejas tribes, they also wanted to be part of this study, so they chose a few ponds for them to monitor as well. Next slide. So some of the partners that we've been working with throughout the years include Viejas, like I mentioned, so they were part of our pre-holiday sampling and special study. San Diego River Park Foundation is pretty active in letting us know when they see blooms, and they're very interested to participate in next year's pre-holiday sampling that we'll do. Vista Irrigation District, they are the ones who monitor at Lake Henshaw, and they share their weekly cyanotoxin monitoring results with us. And then finally, the city of San Diego, they manage many of the reservoirs in our region, and from time to time, they also share their cyanotoxin information. And next slide. And then looking ahead to next year, we'll continue our incident response and acting on our satellite notifications. We'll do the pre-holiday assessments, and we have 5 sites that will be funded by State Board. And then we are also very interested in to participate in the statewide special studies that were presented by the FAB folks at State Board as well. And that's it. Thank you.
All right. Well, thank you so much to all of our coordinators and organizations that presented today for that update at the end of the year. So we're going to take a quick break here and be back at 10:15 for more presentations to come. But grab a glass of water, run to the bathroom, and we'll see you in a little bit. All right. Well, up first for our research presentations today. We have Chris Meach from the Office of Research and Development at the EPA. Chris, would you mind sharing your slides?
There you go. Can you see
Okay,
them?
great. Well, go ahead. Thank you so much.
All right. You hear me okay?
Yes, I can hear you.
Great. Okay. Well, thanks for the invitation to come and talk to this great group of folks doing a lot of great monitoring and risk management for HABs in your state. It's really a pleasure to see all the work that you have going on. I'm
Chris,
going to
I don't know if
yeah.
other folks see his slides? I can't see your slides.
No, can't see him.
Okay, it might have been. How about now? Oh, here I see I have to share.
Okay, cool. Yeah, I think
About
it's
now?
starting to share now. Just taking a
Got it
second.
now?
Looks good.
Okay,
Thanks.
sorry about that. Little clunky on Zoom. Anyway, so this work I'm going to try to give a quick overview of is a collaborative effort between several of our regional offices, including Region 9, your Region 10, 7, 8, 5, and 3, and 1, and our Office of Research and Development, which is where I sit. And many of the PIs on this project are HABS researchers, and they vary from chemists to geneticists, molecular folks. I'm a systems ecologist, and I, for better or for worse, have been trying to corral this team. Tina Laidlaw from Region 8 is our primary lead on the regional side. Wouldn't be happening without all those folks and as well as our partners. And we've been working a lot with the Region 1 folks in your state, taking a lot of cues from them because quite honestly, you all are a bit ahead of this benthic cyanobacteria risk characterization and mitigation problem compared to other places, I believe. So I'm not going to spend too much time on background. I think y'all are aware that benthic cyanobacteria pose a different sort of risk assessment and risk management situation than do phytoplankton blooms. The content on this slide is meant to explain why that is the case. We have to worry about whether cyanobacteria are dominating the periphyton of streams and rivers, and even the littoral zone of lakes, and whether that dominance is producing a lot of biomass, and then if that biomass is becoming mobile or could be easily disturbed, such that exposure increases. So these are all kind of complicated aspects of benthic cyanobacteria that we're trying to address. And we're really, the point of this study is really to try to assess existing both field sampling methods and laboratory methods to come up with some guidelines that we as a regional and Office of Research and Development team can recommend for other states that aren't as far as long as you all on this issue, where we could recommend some approaches on that regard. At the same time, we're also trying to address some of the critical research questions related to the ecology of these organisms and these blooms and why they're occurring and why do they seem to be getting more prevalent. So we think that in order to start answering some of these questions, we have to pay strong attention to method standardization. And we are basing all of our approaches on what partners are doing and the issues that they're actively involved with. most specifically, we've been working directly with, like, as I said, your Region 1 folks, Mike Thomas and Rich Badness, I realize is retired now, Carly, Jamie, and Karen have all been involved, as well as a lot of the folks from Utah, and Heather Bonner and Hannah Bonner and Robin Hendricks have been critical partners as well. So we laid out research objectives at the start of this effort 2 years ago now. We wanted to assess transect methods for characterizing the extent of mats or benthic cyanos within a reach. We also wanted to look at spatial variability to see if that could be confounding matters. And then we assess 2 disturbance methods that the partners had been using and were interested getting some more information on. We conducted a benthic cyanobacteria mesocosm study to do more methods evaluation under controlled conditions and understand the ecology a little bit better. I'm not going to have time to go through that today. And then in the last year and in the coming year, we have been focusing on larger spatial scales and trying to address partner-generated questions related to spatial extent and sampling approaches. Just to give you a snapshot of what we were doing in 2023, our focus was just on seven sites in 6 different states, and then in 2025 and during that 2023 season, we threw everything but the book in terms of sampling methods at this problem, as well as lab methods. And then in 2024, we kind of took the lessons learned from 2023 and we scaled that up to larger sections of the Columbia River, the entire main stem of the South Fork Eel River, with the help of, led by Mike Thomas and Rich. The Virgin River watershed in Utah. We did sections on the Ohio River, and in 2025 we'll be planning to do the North Fork of the Shenandoah River with a probability study. The data in this table you don't really need to focus on, other than to say in 2023 we had a fairly good range in terms of site conditions as well as cyanobacteria coverages encountered. We adopted a transect sampling approach based on the recommendations of Susie Wood and her team in New Zealand. And then we kind of built on top of this other aspects that the partners were concerned about and the researchers wanted to test. We added SPATs to our reach assessment, and at 20 of these sampling locations that we set up, we did a cover assessment. It's the same cover assessment that Susie Wood and her team in New Zealand recommended, that was developed by Kilroy et al. In 2013. It had 7 different cover categories, and it used this bathyoscope. At 2 of the locations on each of the 4 transects, we asked the team to pick substrates up to do a standardized approach for assessing the substrate with a known area sampled. We composited those, but in some cases we didn't composite them, so we could look at the variability across the reach. And then, as I said, we did disturbance sampling as well, which is shown here. So there was a lot of interest in the partnership about people walking through streams and accidentally falling, or dogs running through a stream, and you'd get this suspension of organic material from the bed, cyanomat suspensions or drifting, and how could we capture how could we capture that in a standardized way? So we came up with using these old macroinvertebrate samplers, a Cerber sampler or a Hess sampler that samples a known area. We mimic a disturbance event. And the other neat thing about what we did here is we assessed the bulk biomass that was disturbed as well as the water parcel. We separated those two out so we could characterize where most of the toxin load was and basically validate that it was mostly, you know, in the biomass. Okay. To standardize the processings of the periphyton or the cyanomats, we use this 2-inch delimiter. We did in situ or removable substrate sampling. We combined that all into a slurry. We mixed that slurry, and then we took aliquots off of that slurry. This is pretty standard techniques for periphyton sampling in streams and rivers. And the nice thing about doing it this way is you can standardize everything back to that known area sampled or the weight of the biomass that was collected from that known area. And just to give you a flavor of what some of these experiment or these pilot studies look like, these are bathyoscope images, different sampling points along the transect at our Columbia River site in Leslie Grove Park. And you know what the crews were characterizing as what the periphyton looked like in terms of its potential cyanobacteria cover or not. As I mentioned, there was 7 different categories to choose from. This became a bit of an issue for folks that are not familiar with characterizing the periphyton, and so we've updated that procedure. The 2 images on the right here are from a site in the North Fork of the Shenandoah River near Strasburg, Virginia. In this case, the crews were characterizing green filaments that turned out to be actually cyanobacteria on analysis of the image, and that was supported by the microscopic counts that we did, the microscope counts. Give you some more flavor for the data. This has kind of standard measures of our visual assessment using the bathyoscope, the cell counts that came from those same samples, and then the ash-free dry mass or the organic content of the periphyton and the chlorophyll content at each of our sites. And each of our instances that were sampled, we had composite samples, and then the box and whisker plots here are from the spatial variability study. I'm not really going to have time to go into this anymore, so I will leave it at that. Otherwise, I'm not going to get through everything that's on here. So in the vein of trying to rank relative toxicity among sites, we've been presenting the information in this way. The sites are always organized in these plots, these heat maps from the Region 10 site on the Columbia River over to the easternmost site in Virginia. And this is just kind of showing how the characterization of relative risk might change with respect to green being minimal risk to red being high risk, depending on what aspects of the site you're measuring. These are surface water samples. These are toxins and grab samples. These are toxigenic genes in the middle here, and then toxins on spats. Really toxic sites with high levels of toxin always kind of show up that way. But then when you're in these intermediate ranges, things can get a little murky when you're trying to make relative comparisons. And this is highly brought to bear here in this graph, which there's a lot going on, but this is the periphyton data now, the composite periphyton samples. I'm just showing the ELISA anatoxin and microcystin results from these sites, and basing them on different ways of normalizing the data. So we can normalize it to a liter of slurry volume, or the dry weight of organic of total mass in the amount of material collected and made and then used to comprise the slurry, or to the organic fraction of the material collected, or we can normalize it to area. And if you're doing relative rankings of sites and relative risk, you can see that these rankings change depending on how you do the normalization. These images off the right are just as a quick reminder of what the cyano cover on average was at each of these sites. The disturbance technique we used, we tested two different approaches, one that was more standardizable than the other, and the bottom line with this information is we pretty much got the same answer using both approaches, but the field crews found both of them to be cumbersome and in the overall risk characterization, not really relevant. So we discontinued the disturbance sampling approach when we went into the 2024 season. A lot of this work was going to try to substantiate measures of assessing, doing a visual assessment of cyano bacteria coverage at the reach scale relative to the potential toxin loads, so you could use cyano coverage as a means of characterizing risk. And the data here suggests, in a nutshell, that we stand a good chance at doing that. All of our relationships between the cyano cover returned by the bathyoscopic images versus either the toxins, which are shown on the left, or the toxagenes, which are shown in the right graphs. The difference between the upper and the lower is just a semi-log plot versus a arithmetic one. And it just shows that these models are significant, and we're hoping that we can keep pursuing this approach, and maybe we can end up on a recommendation there. We did adjust the visual assessment procedure, though, in 2025. We scaled it down. Instead of 7 categories, only 3, and we adopted this point intercept approach to make it more accurate and less subjective. And so this is using a quadrat approach, and at least a couple of our crews in 2024 felt that this was a better way to go about the assessment. So the research last year now focused on larger spatial extents. We did large sections of the Columbia River with a probabilistic design, and in the South Fork of the Eel River, Mike and Rich were very interested in doing a systematic design where they were able to assess, basically put spats in every 2 miles. And the main question there was to determine what's the minimum number of spats that you could use on the eel to assess the entire river for risk. That data should be coming to fruition here pretty quickly. The spats are extracted, and all the data is out at the region, or all the samples are out at the region labs for analysis. We also looked at the Virgin River watershed in southern Utah and did a probabilistic design there. We tested a boat survey method on the Ohio River looking for benthic cyanobacteria there, and we coupled that with a phytoplankton survey. We were using a Ponar sample to get samples that weren't weightable. And instead of the disturbance sampling in 2024, we did pinch sampling following the guidelines that Gonzoli et al. Used, who I think is on this call. And we weren't able to get to the North Fork of the Shenandoah River in 2025 or in 2024, so we're going to try to do that in 2025. And you're going to hear a lot more about this system when Mike talks coming up here in a bit. So with that, I went through about a 30-minute talk, and looks like 20 minutes. So I will end it there, and thanks all the folks that are involved in this effort, including many people that are on this call. Really, really appreciate y'all being involved.
All right. Well, thank you so much for presentation. Like you said, we are at time here. So if folks have questions for him, please, for Chris, please just throw them in the chat or email him. But for now, we will move on to our next speaker from University of Nevada, Reno. We have Joanna Blaschuk. And Joanna, if I said your last name wrong, please correct me.
No worries. It's great. Should I go ahead and share my screen?
Yeah.
Okay, great. You actually did it great. Flash check. Perfect. So great. Okay. Let me go ahead and go in presenter mode. I know there's always a lag, so
yeah, we're still seniors. There we go.
Okay. Great. All right. Well, hello everyone. Thank you for the invitation to speak today. This is actually the second time I've given this presentation after Chris. And so thank you, Chris, for giving an awesome talk and sort of laying the groundwork for what I'm going to talk about today, which is also related to benthic antitoxin producing cyanobacteria. So I do want to start with acknowledgements and just briefly thank all of the contributors, support, and funders for this work. And in particular, I want to highlight Jordan Zipperke, who is a PhD student in my lab, and she did a lot of, or she's leading a lot of this work. And as well as Laurel Gonzoli, who's on this call, and Rosalina Stancheva-Rosova, as well as others for sort of inspiration and support. So it's been a really great team of people to work with. Like Chris said, I'm not going to spend too much time on the background here, but in this project, we're specifically focused on a specific cyanotoxin class called antitoxins, and these are neurotoxins that have been detected in rivers across the globe. So on the left, you can see a somewhat outdated map now of where antitoxins have been detected, and you can see it's sort of spread across multiple continents. And the reason why we're concerned about antitoxins in particular is because when they are in mat materials, so benthic cyanobacterial mats, and they're consumed in large quantities, we often see the death of dogs or of wildlife, and that is obviously of public health concern. And so there are many managers, including many of you on this call, right, who are interested in being able to post signage, inform the public, and do that in a timely manner and in a way that actually corresponds to when the greatest risk is. And so the two main benthic antitoxin producing cyanobacteria of concern that are sort of macroscopically present, there's many that are in rivers, but of the sort of largest mat materials, we really have focused in this project on microcoleus mats and Anabaena, and I have it Anabaena/Cylindrospermum because they're kind of hard to distinguish in the field. But anyways, microcoleus, it grows in riffles. It forms these sort of dark brown, black mats, sometimes purple, on these rocks. And this is relevant for later, but it's incapable of nitrogen fixation, which is interesting because we find it in a lot of low nutrient rivers and nitrogen limited rivers. And then in another part of rivers, more in the sort of side channels, backwaters, slow moving waters, we see these Anabaena cylindrospermum towers that can form. And these are incapable of nitrogen fixation. And so, you know, the ultimate goal of this work is really to follow in the footsteps of lake forecasters. So I have learned a lot about lake forecasting in the past of benthic or of phytoplankton blooms. And ultimately, we would love in my lab to be able to sort of develop models that can help us try to inform when should signage be posted, when is the greatest risk of antitoxin in rivers. So with the rest of my time, I'm going to sort of talk about 3 vignettes in which we're, this is a picture of Jordan peering under the surface of the river, but we're also trying to metaphorically do that to understand more about what's going on in these rivers in terms of the timing of the antitoxins, what might be driving that, and how that might be affecting other organisms, including benthic macroinvertebrates in the river. So to start, the question that we're trying to answer is what predicts the timing of peak antitoxin concentrations? And answering this question is challenging for two reasons. So first is that although there is some potential for remote sensing, and you can see that, sorry, I'm trying to adjust this so it doesn't block my view. Okay, so you can see here on the left, as from Mike Thomas, we have a helicopter view of some of these mats in the riffles. And even if you're standing close to a river like the South Fork Eel, you can see the extent of these black mats of the microcoleus. However, if, for example, you're in the Scott River watershed, which is in Northern California, the blooms are much more cryptic, right? So microcoleus has this light brown color. There's a lot of canopy shading, right? So it's pretty labor intensive, as Chris pointed out, that you have to go out and collect the mat samples and estimate the cover. And it's not really something you can do with sensors or remote sensing that easily unless you have the right type of river. Another challenge is that a lot of Susie Wood's work in New Zealand, right, someone we bring up a lot because she's done a lot of foundational work, they have kind of shown that there's not really one unifying abiotic predictor of variation in antitoxin concentrations through time. And here, microcoleus used to be called Firmidium or identified as Firmidium. And here I'm showing you some of their data from their summer season across 8 different sites. And you can see every site is unique in its temporal patterns. And so really when we're thinking about prediction and forecasting, just because antitoxins are peaking in one river doesn't mean that in the same river network, they're going to be peaking at the same time. And so when I learned about this back in sort of 2019, 2020, especially with conversations with Laurel, I, at the time, was also doing a lot of metabolism modeling in rivers, and through those conversations, really came around to wondering whether there could be a phenomenological approach to prediction of the timing of benthic cyanobacterial antitoxin production. And so what this means is that if we put out dissolved oxygen sensors in the rivers, we can use a modeling approach that I'm not going to go into to estimate sort of the total benthic autotrophic activity in a reach. And oftentimes that also sort of varies through time over the summer. And so I was kind of curious in understanding whether we could use that as a proxy of the timing of antitoxin production in these rivers, or at least of the extent of the microcoleus mats. And so if it in fact has that relationship, we would be able to then predict when the mats would be the greatest and when antitoxins would be greatest. So the question we're really trying to ask is, to what degree do processes that shape overall productivity dynamics in rivers predict the occurrence and dynamics of toxin-producing benthic cyanobacteria? And we had sort of a range of hypotheses that, maybe if the green line is GPP, or that autotrophic activity in a reach, and the cyanobacterial cover is in yellow, and then we have the antitoxin concentrations in blue, and we have our Mediterranean climate in Northern California, right? So we have these low water flow periods. We were wondering, would we see synchronous dynamics? Would the timing of the cyanobacterial growth and the antitoxins be delayed relative to total growth in the channel? Or would we see sort of early peaks in antitoxins that have been suggested by some laboratory studies? So we decided to do this work in Northern California, where many of you are familiar with, and that's partly because we knew from previous work that, in these Mediterranean climates, we have the development of these extensive mats because we don't have flushing flows during the summer that can remove them more frequently. And we also knew that they were quite pervasive. So we chose 3 different rivers that included the Salmon River, the South Fork Eel River, and the Russian River. And in 2022, we sampled them biweekly from June to September based off of previous work. And then in 2023, we decided to drop the Russian River because we didn't actually detect much, if any, microcoleus during our sampling period. It actually turns out that it peaked after we stopped sampling, but that's fine. But instead, we focused our efforts on sampling weekly at the South Fork Eel River. And during each of those sampling events, what we did is we followed a modified swamp protocol. So we had our sensor, our DO sensor, from which we were going to estimate the metabolism, or that gross primary productivity. And we had 3 150-meter reaches upstream of that, so kind of in the footprint of the sensor. And then from there, we did benthic surveys at 11 different transects, and we collected composite benthic mat samples. And with those, we did a ton of microscopy, identified what was in the samples and their relative abundance. We extracted the anatoxins and had them shipped off to Greg Boyer at SUNY ESF, that we're eternally grateful for running our LCMS-MS analyses to get the different congeners of anatoxins. And we modeled the metabolism from the sensor data. That's kind of, some of the images from that data collection period. So I'm just going to show you some preliminary results today. I don't have all the answers. We're working on it right now with Jordan, but the first thing I want to show you is how the synchrony between the mat extent, or the percent cover in a channel, and the toxin concentrations really depends on which taxa you're looking at. So I'm just showing you the weekly data from 2023 at one of our locations in the South Fork Eel. And this is, the font got a little messed up, but on the left-hand side, we have anatoxins kind of declining. So the greater the bar size, the more anatoxins there were. And on the right-hand side, and these dashed lines and dots, we have the percent cover in the channel in that 150-meter reach. And in the blue, we have microcoleus concentrations and cover, and in the gold, we have the Anabaena/Cylindrospermum, because it was hard to distinguish those in the field, but they're both anatoxin producers. And so what we saw was that the toxins, they slightly peaked a little bit ahead in the Anabaena and Cylindrospermum, but they generally peaked around the same time frame in late August. But what was different between these two taxa was that the Anabaena and Cylindrospermum mats kind of came and then they went and were mostly gone by the time September rolled around, whereas microcoleus really only got started after the Anabaena peak and started and continued to expand from there. So when we're thinking about prediction, there's models that can predict hysteresis curves. So in the Anabaena Cylindrospermum, as the percent cover increased, we saw an increase in toxins, and as those mats started to senesce and slough off, and we saw that decline, and we also saw a decline in the toxins in the cells themselves, like per unit mass. Whereas for microcoleus, we don't see a hysteresis pattern. Instead, we kind of see this increase and then a blip where we see an increase in the toxin concentrations, and then percent cover continues to increase, but the actual amount of toxins per unit mass of mat does not increase as well. So again, this just points out that if you're interested in understanding, the timing of the toxins, it may be synchronous across these two different types of benthic cyanobacteria, but how that actually relates to the amount of mat material in the reach is different between these. So if we go back to some of the original hypotheses, unfortunately, the metabolism data was a little more sort of stable than I originally anticipated it might be. But one thing that we're looking into across all of our different sites is just this timing of the microcoleus mats starting to increase right as the gross primary productivity, or that total autotrophic activity in the reach, starts to decline. So that might help us with some of that prediction and modeling that I had been talking about. So again, there's some preliminary evidence that at least for microcoleus, we see peak abundance after green algae in the reach starts to senesce more rapidly. And I'm just going to flash this at you guys. Don't look at it too closely, but basically we found, similar to New Zealand, that every reach was unique, and that that really precludes any sort of generalizable regional forecast. So you can't just monitor the South Fork Eel and say, hey, every river in this region is going to be the same as the South Fork Gill, right? It's every river kind of has its own dynamics and own timing of peak antitoxins. So I'm just going to briefly touch on the species co-occurrence. I'm not actually going to show too much for the sake of time because I shortened this talk from another one. But another sort of interesting tidbit that we're looking into with some community ecology modeling is thinking again about how microcoleus itself can't fix nitrogen, but it grows and it really proliferates in these nitrogen limited rivers. And so the question that we're asking really centers around, who and when is microcoleus occurring with? And so here you can see, for example, both in June 2022 and July 2024, I have two examples, but we saw some in 2023 as well. We see that microcoleus is growing on the same rocks as nostoc, that's a nitrogen fixer, but more microscopically, we do see epithemia inside of the microcoleus mats. And so maybe that is facilitating the growth of the microcoleus despite it growing in a nitrogen limited stream. And so even when you see that as well with the Anabaena and Cylindrospermum, as I pointed out before, we see this peak in the nitrogen fixers before we see the start of really more expansive growth of the microcoleus. And so we're tackling this question with a mixture of, like I mentioned before, a bit of modeling, but also looking at the DNA of and who's there in the mat samples, and both from like I said, a sequencing perspective, but also a microscopy perspective. All right, so with the last sort of couple of minutes of my talk, I just want to talk about a side project that got started by a former technician in my lab, Megan Hickey, who was really, she came from Vermont. She was really interested in benthic macroinvertebrates. And so we had this side project that I'll describe right now, but Shelley Pnay, who works with Mary Power at UC Berkeley, is helping us finish up the identification of the bugs for this side. So what we're really interested in understanding was in 2018, this study by Anderson and others came out that showed that for many invertebrates, the LC50s, or just the levels of antitoxin concentrations that can kill or otherwise impact invertebrates, was actually quite low and at environmentally relevant concentrations when you expose them to crude extracts. And however, at the same time, there has been some work out of New Zealand that has shown that if you actually isolate those toxins from crude extracts, they didn't actually observe any toxic effects. So there's kind of this unclear question remaining of how much are the toxins themselves affecting the benthic macroinvertebrates versus potential changes to the community composition of rivers with these proliferations as a result of changes in the habitat. So here on the left, you can see a picture of one of these microcoleus mats, and you can see if you kind of flip it over, there's a bit of sediment at the bottom. And when it wraps around these rocks and sort of covers parts of riffles, it creates really different conditions inside the mat, as you can see on the right-hand side, relative to the river water. So you can imagine, if most of your riffle is covered, let's say, with green algae, that's well aerated. But in these mats, we have anoxic conditions, changes in pH, all of those sorts of things that can be stressful to organisms. So the question we wanted to ask was, how do microcoleus mat proliferations affect benthic macroinvertebrate or grazer community composition? And we did this, again, this was a side project, so it wasn't a sort of really extensive sampling, but we sampled on 2 different dates in 2022. We did triplicate rock pairs where at 3 different reaches, we collected 3 different rocks covered with microcoleus mats that were at least half a meter apart, but within 1 meter of each other, so they were experiencing the same environmental conditions. So 3 microcoleus, 3 green algae. We scraped the entire rocks into ethanol. And like I said, I'm going to show you some preliminary results, but identification takes a long time, so that's still ongoing. And I just want to briefly mention that we tried to look at toxin assimilation, but we also sort of held the bugs and vials in the fridge for a subset of them. And I think in that time, the toxins may have degraded. So more on that in the coming years. But in terms of our preliminary results, what we saw was that we saw at least for our preliminary results, a community shift towards a greater abundance of more tolerant taxa, such as midges, relative to more sensitive taxa, such as mayflies. So here I'm showing you midges per centimeter squared, where the green is the green algae rock and the brown is the microcoleus rock. And you can see in this instance, there is, we haven't finished identifying all the rocks for this reach yet, but for the ones that have triplicates, we do see an increase in midge density relative to the green algae rock. And there's a little bit of evidence of declines in mayfly density in the microcoleus. But we also sort of realize that these differences between the rocks are quite stark, where the microcoleus mats really wrap around the rocks, so normalizing by area versus sort of taking a ratio may misrepresent what we're seeing. And so when we actually looked at the ratio of midges to mayflies, we actually saw a really substantial change in the amount of tolerant taxa relative to more sensitive taxa on these rocks. So the implication here is that we might be sort of shifting the emergence of insects, might be shifting the benthic communities, but again, there's more on that to come. And I am out of time, so I'm just going to wrap up that, yeah, we're learning that taxa-specific considerations when you're thinking about how toxins relate to mat extent are important, and that these benthic microcoleus blooms might be shifting the community composition of benthic macrovertebrates. Thank you. Yeah, that's it.
All right. Thank you so much. Very interesting. We look forward to following your work in the future.
Great, thanks.
Yeah. So if you have questions for her, we are out of time, so please throw them in the chat or email her, and hopefully she can get back to you. Yeah. Up next, we've got Mike Selkman from the River Basin Commission. Are you here, Mike?
I am. Can you hear me?
I can.
All right. Can you guys see my screen?
Not yet.
All right. Well, we're supposed to have a little bit of technical difficulties, work up the anxiety to the presentation. Let's see. Share. And you
There
should
we
see
go.
PowerPoint now.
Yeah, it's coming up. Just loading. All right. Yeah, it's not quite in presenter mode yet. Can see the slide deck though.
So I have it on presentation now.
Not yet. I'm still seeing your slide deck with all the slides on the side. It might mean sharing a different window, perhaps.
Great. Bear with me.
No worries.
I've been battling all day just getting my microphone to work, so I'm
Oh
not
no.
surprised I'm here as well. All right. So if I just do screen, can you see everything now? And then full
Yeah,
screen?
yep, now it looks good.
All right. I guess I'll do it without my notes, no big deal. All right. So since hopefully everybody had a chance to get a cup of coffee or something, and while I kind of floundered at the takeoff. So this presentation is just a representation of what I presented at the CCHAB conference in Portland, Maine this year. And because we're still haven't gotten the opportunity to quality assure data and kind of process everything over this project, this is really more of a focus on how different agencies are coordinating to kind of take different prongs and different approaches to really hit the North Fork of the Shenandoah really hard from a couple different angles. So that's kind of the objective for today. A real quick background to this, starting around 2021, the North Fork Shenandoah was closed for about 11 and a half miles. And it was due to the risk of toxins being present. The following year, there was a similar bloom where more point source reaches were closed down. Most of them were river access points. But ultimately, it raised a lot of concern in the community, which went down to Richmond, the capital, and got a lot of political interest. And from that, one of the highlighted areas for HABs was this North Fork Shenandoah. There's a sister project in Lake Anna in Virginia, another recreationally valuable water body that kind of came through the same funding channels. But for this presentation, I just want to focus on the Shenandoah. You'll see that there's a link. This presentation will be available after I guess we meet today. That link takes you directly to Virginia DEQ's language around the Shenandoah HAB investigation. To cut through all the language and kind of simplify things down. Just out of curiosity, is the names of everybody that's in the chat, is that showing up on the screen as well? Or is that hidden to you all?
That's hidden.
Okay. It's kind of blocking part of my screen, but not a big deal. All right. So to kind of summarize the project objectives, it's to inform the extent and risk of benthic HABs. As we've kind of heard from the last couple of presentations, extent is pretty variable. You can look at a long 60-mile stretch of river and have very localized blooms. You can view it as one long continuous bloom. So the definition of extent is something that we wanted to discuss, as well as the risk. The risk, again, is something that we discuss a lot, where water column versus intercellular toxins are a consideration. So these are things we're hoping to kind of define, at least in our perspective for this project. We want to identify and understand the factors and processes leading to HAB formation, persistence, and decline. It kind of goes back to the modeling approach that was just presented. We're going to take a watershed scale kind of look at the North Fork and see if we can identify the primary sources and factors that contribute to the formation of HABs. And then finally, this fourth bullet point, since so much of this was focused on kind of describing what's there, this fourth point is sort of pushing the science. Is there new technology? Are there other approaches that we can take to address this issue in upcoming years? So point number 4, I'll talk about a little bit towards the end of this presentation, bringing in things like near field imaging, drone flights, hyperspectral imaging, things like that. So this is a coordinated effort, and I don't think this would be easily accomplished without every single partner in this project sort of taking a piece. So to start, USGS is functioning from their gauge stations. So they're looking at continuous data and really what's in the water column, what's moving past their gauge stations. ICPRB, so I guess the name got cut off. I'm with the Interstate Commission on the Potomac River Basin. The Shenandoah is one of the major tributaries to the Potomac. We were looking at benthic quantitative and qualitative sampling. So we were going out between the gauge stations and actually collecting the benthic attached algae. DEQ is handling the water chemistry. They modified their, I guess, sort of normal ambient water sampling to support this project. And then VCU, it was doing the aerial imagery part. So if there's any questions about any piece of this, all the contacts are, on the right side of the screen there. So just to kind of give you an idea of where this system is, the Potomac River Basin is kind of highlighted in that darker color, and the lighter yellow is the North Fork Shenandoah. The North Fork and the South Fork Shenandoah come together at Front Royal, right underneath the O and Blue Ridge Mountains, and that's everything downstream of that becomes the main stem Shenandoah. Then the Shenandoah meets at the confluence of the Potomac and Harpers Ferry. So you have Virginia, West Virginia, and Maryland all right there. And that's an interstate interesting place to be taking water chemistry. So that's kind of gives you the idea of where we're working. And looking at the North Fork specifically, you'll see that we're taking this bracketed coordinated approach. So the USGS, it has their gauge stations upstream and downstream. The Mount Jackson and Strasburg sites, Mount Jackson being upstream, Strasburg being downstream. USGS, according to their calendar, when they get out to take their water column sampling, they're kind of the trigger for when ICPRB and DEQ go out to take water quality samples. So all of these samples should be collectively taken within the same 2-day window. The points that are in between the gauge stations, so if you're looking at the map between the triangles, these are what we were calling longitudinal survey sites, and they're based on accessibility. Semi-weightable, ideally, all of our sites would have been easy to get out to, maybe no deeper than, your knee. The reality is the North Fork's easier to navigate than the South Fork, which we were also sampling in, but all of these sites, depending on the time of year, required deep wading, if not bringing a dive mask and having to take samples. So the navigation, that semi-weightable definition is important. I know a lot of the existing literature and methodologies, it should be a weightable system. We're really pushing that definition. This reach, or when we went out to look at the benthic mats, there should have been a historical bloom associated with it. So these are places with, a history of issues. And we tried to pick points that were relatively equidistant between the gauge stations to try and get an idea of the entire system. And then DEQ, limited by personnel and having other obligations to the state, they actually hopped every other site from Mount Jackson down to Strasburg. So we have water chemistry for every other site paired with the benthic samples and the USGS gauge samples. So USGS, their approach falls into these kind of 3 columns. There's continuous monitoring, meteorological, hydrological, water quality, and they installed live imagery at a lot of the bridges because they had a power source and the ability to uplink that live image. There was discrete sampling once a month where they were going out and taking water column grabs, looking at algal taxonomy as well as toxin production. And then they also have a kind of a spur project looking at eDNA and rDNA that was going off to one of their USGS labs. Finally, there were synoptic surveys where, as you go down the North Fork Shenandoah, looking at sort of the geological layers, there's some really interesting. This is a karst underlying system, and there are some interesting geological points, these kind of interfaces and upheavals where we think groundwater could be something to consider in this system. And finally, continuous DO loggers were put out to calculate stream metabolism. So to take a look, so up in the upper right is the North Fork Shenandoah River with Mount Jackson and Strasburg identified, the 2 primary gauge sites for this study. We have the stream gauging being reported every 15 minutes, the solar radiation paired with that. Water quality, your standard water temperature, conductivity, pH, and dissolved oxygen, turbidity was all being reported. An additional nitrate sensor was installed at these gauge stations as well. So we have paired nitrate values above the treatment, the bloom site, which is downstream of Mount Jackson. Downstream of Mount Jackson and upstream of Strasburg. So kind of treating that as a closed system. An interesting thing, we have flow data going back a very long way for a lot of the sites in this study. Strasburg being one of the oldest gauges at USGS at 1925. So we have a lot of data to go on, kind of going back to understanding the hydrology in this system. And finally, there was a chlorophyll and phycocyanin sensor installed. with the nitrate and the water quality sensor, and that was reporting total chlorophyll, green algae concentration, blue-green algae concentration, as well as, all these things are kind of being extrapolated from the sensors on the chlorophyll sensor. Some kind of early results, we see that things like nitrate are kind of linked to flow. Again, we haven't really dug into interpretation of this data yet. It's still preliminary, so this is just more of a things to come, kind of early on, interesting correlations happening. Same with dissolved oxygen, as was reported in some of the earlier presentations today. We see this high production period that collapses as you go towards winter. But DO and pH, given the proximity of the sensor to a bloom reach, there's some things we need to discuss about how far we can really describe the metabolism at any one of these sites relative to where the gauge station was. But we have this DO and pH getting at the in-stream metabolism. Here's a quick snapshot of what the continuous in-stream imagery looks like. And this was nice to be able to check it out real quick and get an idea of what's happening in the system. Moving on from the gauge sites, I'm going to talk a little bit about the benthic and the qualitative sampling. Really, there were two key components to this survey. There are the static longitudinal points that was going out once a month, again at the trigger of USGS going out and doing full site surveys. But then there was also response-based floating surveys where we were taking canoes out on the river and responding to where we heard problematic blooms were occurring. In some cases, we were going out preemptively in reaches that had historical high production and trying to get a baseline. But for the most part, we were responding to reports from the local community. So we used the California surface water, the swamp method, but we modified it because we had to get the North Fork and the South Fork done in a very small window. It's the reality of logistics. So we cut it from 11 transects down to 9. We took quantitative and qualitative grabs. The quantitative grabs I'll describe in a little bit. The qualitative grabs were opportunistic grabs of what we saw most predominantly at these sites. And the objective there is to get the most complete taxonomic list of what was occurring out there. Since we are kind of starting at square one with benthic HABs in this system, that taxonomic defining that taxonomic list is important. We took a YSI, just field reading at every site, and that should be paired with the water chemistry that was also occurring. So all that kind of comes together. Looking at the California swamp method, the substrate sampled included cobbles, large gravel, wood, macrophytes. We dropped out wood and macrophytes because in this system, given how depending on the year and the 2 years of this study, it was actually historical drought. But a lot of woody debris is very short-lived. It kind of gets pushed out of the system given how flashy it is. So we didn't sample on down trees or within macrophyte beds and things like that. We generally had to kind of modify where we sampled a little bit. And ultimately, because we were diving, a lot of times we didn't have any kind of like scuba equipment. So finding a representative piece of substrate that could be brought up to the surface and sampled on was pretty critical, a pretty critical piece of the method. A general site looks like this, where there was a left bank, middle, and right bank YSI reading. upstream and downstream. This was to get at trying to detect groundwater influence. In some cases, you actually can see changes in things like conductivity, where it seems like a site may be more influenced with groundwater. So we wanted to note that. That's why we kind of, again, bracketed each site that we sampled. We had a random start at each transect. So when you got to the first site, it was left, center, or right, random number generator as to where we started. And then all of the samples were combined for a homogenized sample of 9 subsamples into one 1-liter jar, and that's what was delivered to the lab for processing. Since we weren't looking at diatoms, we focused on macrophytes, so we were cutting out as best we could all the algae that fell within the delimiter, and again put that into the composite sample. We would scrape the rocks, but we didn't go as far as to take a razor blade or anything that would be ablative to the rock to try and get all the way down. The qualitative sampling approach, we were taking macroscopic photos, and these are going to be used. They're sent off to Dr. Kristanova at GMU, and we're building that taxonomic key for this system. In-stream, as well as macroscopic images, will be put together for this project. And ultimately, this is kind of what the data set's starting to look like, is we're getting a really good assemblage of what is present, when it's present. It's all confined within the survey reach. So it's kind of each one of these points describes just the area that we're sampling in. It can't be extrapolated out, as we've, again, was mentioned earlier today. I was really enjoying these presentations. The variability between the sites is pretty impressive. This is giving us that idea, that basic question of what's here, where, in the kind of the continuum of the river, and when is it showing up. Finally, I want to highlight VCU with their aerial imagery. And to this, I want to kind of punt to VCU and Dr. Zimba's lab. We're still waiting to get the complete hyperspectral data set. This drone that you see in the center of the screen costs nearly as much as the budget for all of the in-stream sampling. So for them to come in and help us on this project was really a privilege. And this is what the data kind of roughly looks like for one of our sites. This is relative phycocyanin abundance, and over the course of a year, you can see that hotbeds kind of emerge and then fall away. We're still trying to figure out how to interpret this data. So for now, it's an interesting picture that shows promise, but we're still, again, trying to take the time to interpret all this. We're just now getting the data for it. But ultimately, they went out at a subsample of North Fork sites that we were working at and really just focused on their own project design, getting the hyperspectral imaging down for the sites that have the paired water quality, the paired benthic sampling, the water column sampling. So hopefully we can go back and connect these images to what we've collected in the field and at the gauge stations. Finally, the participating labs. We've not going to have time to talk about USGS's labs, the Virginia State labs. That's all their standard ambient monitoring. And I've kind of just contact Paul Zimba or Dr. Zimba at VCU if you're interested in the hyperspectral imaging. GMU is the lab that's heading up the taxonomic IDs, the pigment analysis, the toxin analysis, and the biomass of the samples. A qualitative mat sample are delivered pretty much same day. We coordinated one of their, usually it was a grad student. If not, it was just a long day of driving. But we got the samples delivered same day that they were collected. Once they were to the lab, they were held at 4 degrees Celsius, and they were basically spread out in one of these pans, kind of homogenized, and then turned into what they were calling a cylinder or a sausage. And from that quantitative composite cylinder or sausage piece that you see in the center right of the screen, we had 2 ELISA toxin analyses, 2 LCMS analyses. The pigment component was broken into fluorometric chlorophyll analysis, standard chlorophyll A, B, and C, um, phycobilins, and then from that there was an ash-free dry weight broken into triplicates, taxonomy, and then similar to what USGS is doing, there's molecular work on that last eighth of the sample. So each one of these samples is kind of being teased apart, so it's all relational. We can go back and correct for, or I guess calibrate for the amount, the volume, the biomass of the sample, as well as the toxins and pigment numbers, things like that. So as we go into the start of phase 2 and supporting projects, the USGS stations ran up until December 31st, 2024. We're still kind of looking at, is there any future to this project? Can we keep the stations up and running? So all that's kind of up in the air right now. As it stands, field collection, both the benthic collection, the water quality with Virginia and the USGS gauge stations have stopped at this point. The lab processing, so they're kind of the lagging component of this project, but they're catching up. We should be getting the final data sets hopefully sometime the next month. And then phase 2 goes into watershed modeling, where we're going to be taking a look at factors leading to the HAB formation, persistence and decline, that language directly pulled from the Virginia HAB 30 project document. One thing to point out, there's some non-contract supporting research that was coming from the university's grad students that kind of took the opportunity knowing that there was going to be paired data sets for this. So we have paired spat sampling out at a lot of these sites. We have, actually, I guess Chris was here. There's some national methodology comparison to what we're doing here compared to Maryland, compared to West Virginia. So there's the Mid-Atlantic piece, and then we're kind of expanding it out to taking a look at other national methodologies. We've also done some work with algal toxin test strips, and that was with Abraxas, which is now gold standard, looking at antitoxin. And these are tools that the friends of groups, or the river keepers, these people that are really invested in the river locally, can monitor and have a tool to understand sort of the threshold of and get at that risk question. So that's really kind of the rundown. There's been a lot of folks working on this. Like I said, a large number of USGS folks with all the tangent projects they're working on. The Valley office in Virginia DEQ, EPA Region 3 has come out and helped us more than a couple times with the sampling. And again, the partnering universities, Virginia universities, it really has been a team effort. And then finally, the local communities, even portaging boats and shuttles and things like that. There's a lot of interest and concern in this river. So to have a community that's willing to help is really appreciated. So with that, these are all the contacts of the different folks to reach out to. And if there are any questions, I guess I'm happy to take them.
Yeah, thanks so much. We're actually out of time.
Okay,
So please
sorry about
throw those into the chat or email. Thank you so much for your presentation. We'll move right along. We've got Isha Kalra, and she's from USC. If you want to share your slides. It's not in presenter mode yet, but I can see your slide deck.
Yep.
I think I'm looking at your presenter view. So
Oh,
yeah, maybe share the other screener.
yeah.
Is that better?
Still seeing the
Okay.
view.
You want to go back to sharing your screen, we can help you troubleshoot it. Okay, so up on the upper portion, if you want to go back to presenter view.
Oh,
Oh,
now
there we
it's
go. It
great.
actually just worked. Okay. Otherwise, there's a
Okay,
swap
Marissa.
views button above the left panel.
Okay. Okay,
right,
good to know.
ahead.
Yeah, thank you. Yeah, thanks everyone for inviting me to give a talk on the recent project that we finished, which deals with temporal and spatial dynamics of harmful algal bloom associated microbial communities at Clear Lake. This project has been a collaboration between University of Southern California and Dave Caron's lab and Eric Webb's lab, as well as SCORP. So Jamie, Ali, and other people at SCORP have been helping us with this project. So let me go ahead and give a little bit of background. Clear Lake is one of the oldest and the largest natural lake within California, which has a distinct morphology. So you have a largest upper arm on the western side and Oaks Arm on the southeast side, as well as the lower arm. The lake is generally warm, shallow, and polymictic throughout the year, which leads to a eutrophic environment in the lake. The lake has also had historical water quality issues with mercury contamination, pesticide runoff, invasive species, and high primary production has been documented at the lake since 1970, where we've seen cyanobacterial blooms recorded. In recent years, the harmful algal blooms have been increased in frequencies as well as their toxicity. And these cyanobacterial harmful algal blooms have been composed of multiple toxin producing organisms such as Dolichospermum, Lyngbia, Microcystis. So here is a graph showing the yearly trends in the microcystin concentration at Clear Lake in the past several years. So cyanotoxins have been measured by CLCMP every year since 2014. So here you can see at different arms of the lake, how the microcystin concentration changes. So they're really concentrated in, especially in the lower arm and the Oaks Arm region of the lake, and they vary year to year. Especially 2016 recorded one of the highest microcystin levels seen in the lake, which was around 16,000 micrograms per liter. And microcystin levels have frequently exceeded the warning and dangerous trigger levels in the lake. So I showed you the annual changes in the microcystin concentrations, and here are the monthly patterns. And as expected, you see an increase in microcystin during the summer and the fall months, specifically during August and September, where the toxin concentration are the highest. But you also see yearly variation in these highest microcystin concentrations, as you can see from the different years depicted in the different colors here. So overall, some of the outstanding questions that we were looking at is to understand what specific taxa are the cause of toxins and predominantly microcystins that are observed in the lake. What is the effect of toxin-producing species and or cyanotoxin on the species richness and community composition of the co-occurring microbial assemblages? As we know that we have a very intricate food web where all the organisms are interacting with each other. So the heterotrophic bacteria are interacting with cyanobacteria, as well as microbial eukaryotes are interacting with the cyanobacteria and might be contributing to their frequency of harmful algal bloom in the lake. And also to understand what abiotic and biotic factors control the microbial community structure and influence the cyanoHAB occurrence patterns at Clear Lake. So to answer these questions, our overall project goals was to provide an extensive characterization of the species richness and community composition of the overall planktonic bacterial and microbial eukaryotic assemblage using DNA sequencing, specifically looking at the bacterial and the eukaryotic ribosomal rRNA gene amplicon sequencing and looking at the whole community structure and not just focusing on the cyanobacteria. And also to investigate the spatial and temporal dynamics of the community, as we have seen that there is a huge variation in the concentration of toxin in the lake, where the toxins are more concentrated in Oaks Arm and Lower Arm. And also there's a change in the temporal variation of the toxin, where the toxins accumulate more during the summer and fall months, as well as yearly changes. So to investigate that, the sampling was carried on for 3 years, 2019, 2020, and 2021, where we specifically looked at August, where we find the highest microcystin concentration, as well as a seasonal sampling was done during 2021, where samples were collected from July, August, September, and October. So in addition to looking at spatial and temporal dynamics, we were also interested in evaluating the influence of environmental factors and cyanoHAB proliferation on the overall community structure. And we specifically focused on these parameters shown down here. So total phosphorus, conductivity, chlorophyll, nitrogen, microcystin, oxygen, temperature, and TN to TP ratio. So looking at the physiochemical conditions associated with the blooms in Clear Lake during our sampling period, we sampled 5 different sites at Clear Lake. So we sampled in the middle of the upper arm. We sampled the Narrows, Soda Bay, a site in Oaks Arm, and 1 site in Lower Arm. And as I mentioned before, we sampled monthly during July, August, September, and October. And for our interannual variation, we just looked at August of 2019, 2020, and 2021. So here is the microcystin and chlorophyll levels during our sampling period. And as you can see, for microcystin, we have really high concentration of microcystin during September of 2021, which is where our highest microcystin was recording for our overall sampling period. And this was also observed in chlorophyll levels, where also chlorophyll levels were highest in September 2021, and especially in Lower Arm, as we have seen before. For the yearly sampling, we saw that August of 2021 had the highest microcystin and chlorophyll levels, again, sort of like implying that 2021 was really the year when toxin and chlorophyll levels were highest in Clear Lake. So one of the first results is looking at the overall bacterial community composition. So again, we sequenced the 16S rRNA gene of the overall bacterial community. And this is the seasonal sampling that we did. And as you can see, that cyanobacteria make up almost 25 to 55% of the total bacterial sequences. So they really dominate the overall bacterial community, which is not surprising. And cyanobacteria are also dominant during the fall months. As you can see from here, they really peak during September and October sampling. And these bar graphs are average of all the sites. So you see the variation in the different sampling sites that is observed in Clear Lake. And again, looking at the interannual variation, we can again see that there is a significant variation year to year. So cyanobacteria overall levels were highest during August 2019, and they were lowest during August 2020. So other bacterial organisms belonging to proteobacteria, Bacteroidota, and actinobacteria really dominated during 2020. So you see these variations year to year, as well as the monthly variation in the overall bacterial community. Going forward, we wanted to look at how the community changes with time. So here we're looking at principal coordinate analysis of the overall bacterial community, where each point you can imagine is the whole community kind of collapsed onto one point. So different colors represent different months. So you can, and different shapes represent different sites. As you can see that the samples are really neatly divided by month. So you see the samples being aggregated together here. So summer community looks very different from the fall community over here. But when you start looking at the sites, you do start to see that the lower arm site, which is in the squares here, kind of is similar as compared to the other sites. So there's more homogeneity in the lower arm site compared to the other sites at Clear Lake, which are more distinct month to month. Now, taking these points and then expanding and looking at the entire cyanobacterial community, we can really nicely see the succession of different cyanobacteria in Clear Lake. And one of the most surprising thing we saw was this dominance of the picocyanobacteria synobium, which is generally missed by microscopy because it's so small, really dominating the western part of Clear Lake here, especially in the summertime. So synobium is generally found in oligotrophic environment where nutrients are less, where it kind of outcompetes other organisms. So it kind of makes sense that it's more prevalent during summer period in the western part of the lake. But then we saw the succession of like Lingbia being really dominant during July of 2021, and then but in August, followed by a Dolichospermum bloom, which was dominant in the western part of the lake as well as Oaks Arm. But then you start seeing Microcystis kind of being picked up, and this coincided with increase in total nitrogen levels in the lake. So that makes sense that you have a competitive environment for Microcystis. But then in September and October, you really start seeing Anabenopsis kind of taking over the community in the western part of the lake as well as Oaks Arm. But Microcystis is really, really dominant in lower arm in September, which again coincides with the highest microcystin levels that we found during our sampling period. So that makes sense that Microcystis was probably actively producing toxins. And along with that, we have contribution of other fall taxa such as Planktothrix and Limnothrix that kind of follow the Anabenopsis bloom in Clear Lake. And here are some of the microscopy images of Lingbia, Dolichospermum, and Microcystis that we sampled during our sampling period. So as I talked about, we're not only interested in cyanobacteria, we're also interested in understanding the eukaryotic community composition in Clear Lake. So here is again a principal coordinate analysis of the entire microbial eukaryotic community. And here also you see that the samples basically clustered together by month, but August kind of shares a lot of similarity with other months. So there's a seasonal succession, but it's slower than what we found in bacterial community. And then again, looking at the community composition of the eukaryotes, we see that chlorophytes really dominate during the summer months, as well as metazoan sequences were more common in lower arm and Oaks Arm. And then cryptophyte and diatoms kind of take over during fall. So the entire community of the eukaryotes is also dominated by photosynthetic organisms, which makes sense because Clear Lake has such high chlorophyll levels, which are contributed not only by the cyanobacteria, but also by these other photosynthetic eukaryotic organisms. Then just looking at the interannual variation, we saw that the seasonal succession of both the bacterial as well as the eukaryotic community. And we also see some interannual variation in the overall community. So here is looking at the 16S. Seems like August 2019 was very different from August 2020 and 2021. And kind of makes sense looking at the composition where we see in 2019 synovium is really, really dominant, whereas in 2020 and 2021 you have more contribution from Dolichospermum and Lingbia. Similarly for 18S, we saw interannual variation in the overall community composition where In 2019, you have more of chlorophytes that are dominating the community, whereas in 2020, diatoms really take over the eukaryotic community. Next, we wanted to look at the influence of environmental factors on the overall cyanobacterial community. So here is a redundancy analysis of the overall bacterial community, looking at the different environmental factors that we measured, as well as the top 10 dominant bacterial species. And these are mostly cyanobacteria just because they were so dominant. So here you can see that different points here represent the different sampling months. And the arrows here represent in black either the environmental factors or in red the different cyanobacterial genus that are contributing to that variation. So the primary axis seems to separate the samples by season. So you have September and October on the right-hand side, which seem to be really influenced by the total phosphorus concentration, as well as the organisms that influence that seasonal variation is Anabenopsis and nodularia, which we have seen was more common in the fall months. Whereas the secondary RDA axis kind of explains more of the site-specific differences. So you see that the sites are distributed on the secondary RDA axis, where you see this accumulation of the lower arm sites over here, along with the microcystin levels. So as well as microcystis, kind of showing us this really strong correlation of lower arm with microcystin, as well as the microcystis organism. So next, looking at the Spearman correlation of these different dominant genus that we found during our studies and the environmental factors. So we just took all the samples that we had together and did this correlation analysis with different environmental factors to see how these organisms respond to different environmental conditions or influence the different environmental conditions. So first, we saw that, of course, microcystis was very strongly positively correlated with microcystin levels and was one of the only genus that we found in our entire study that was so strongly correlated with microcystin, making us believe that microcystis is the primary microcystin producing organism at Clear Lake. On the other hand, synobium, that picocyanobacteria that I talked about, which was more abundant in the western part of the lake, was very strongly negatively correlated with microcystin. So we can see this as the presence of synobium might indicate absence of toxin. And it has been seen in other studies as well that proliferation of synobium before microcystin bloom is common, and they're especially can be used as an indicator of non-toxic conditions. Along with that, we saw that Lyngbia was slightly positively correlated with microcystin to chlorophyll levels, as well as Nodularia, Anabenopsis, and Limnothrix were weakly positively correlated with microcystin. Along with that, we saw that microcystis was also strongly positively correlated with total nitrogen, which makes sense. We've seen that microcystis generally follows bloom of nitrogen-fixing cyanobacteria. But synobium was negatively correlated with total nitrogen, again, kind of emphasizing that synobium is more prevalent during conditions of low nutrients. And then we saw that the Nodularia or Anabenopsis strongly positively correlated with both phosphorus and nitrogen, and it was more common during the fall months. Lastly, we wanted to look at the eukaryotic community and its association with different environmental factors. So here again is the Spearman correlation analysis of the top eukaryotic genus with the environmental factors. So we first see that Chlamydomonas, which is a chlorophyte, was very strongly negatively correlated with microcystin and was the only eukaryotic organisms that we found was negatively correlated with microcystin, and which was surprising to us because we expected more organisms to be negatively influenced by microcystin, but competition between Chlamydomonas and Microcystis is well documented. So it makes sense that whenever Chlamydomonas was present, we saw less abundance of microcystin producing Microcystis. But interestingly, we saw some positive correlations of certain organisms with microcystin. So we saw a positive correlation with cyclopoid copepods, which have been shown in one study to graze on microcystis, as well as diatomnesia, as well as and cryptomonas, which actually has been shown in some study that microcystin enhances bacteriovory in cryptomonas. But these relationships are putative and need further confirmation using additional experimental work and statistical analysis. So concluding, we saw that there was a strong seasonal succession within the cyanobacterial and co-occurring eukaryotic assemblage, and which was primarily explained by variation in total phosphorus and temperature. We saw that the seasonal succession in cyanobacteria was often proliferated by diazotrophs with concomitant increases in total nitrogen. So that followed blooms of non-diazotrophs such as Microcystis, Limnothrix, and Planktothrix. And the Synobium, which was previously undocumented in the lake, was a dominant summer taxon in the western part of Clear Lake. Among all the toxin-producing genera, Microcystis abundance was most strongly correlated with microcystin. And we identified several potential grazers of Microcystis, including cyclopoid copepod and cryptomonas, but this needs further validation using statistical approaches and experimental work. And with that, I would like to thank all my collaborators and our funding support. Thank you.
Thank you so much. So again, we're kind of running short on time, so please throw any questions into the chat. And Isha, if you wouldn't mind sticking around to answer some of those, that'd be fabulous.
Thank you.
All right. So moving on, our last talk before lunch today, we have Sarah Ryan and Alex Miguel coming from Big Valley Band of Pomo Indians. So continuing on with our Clear Lake sub-theme here. If you all want to share your screen.
Hey, okay, hopefully this will work. That over here. All right, can you see the screen?
Yeah, that's great.
Wonderful. Hey, everybody, Sarah Ryan with the Big Valley Band of Pomo Indians, and I'm joined by our Water Resources Program Manager, Alex Miguel. We're going to be sharing these slides. It's so exciting to be following another Clear Lake presentation. Some of the toxin data that that study was based on came from our program, so great to see it being used in a lot of different ways to determine what's going on Clear Lake. However, in the last couple of years, we also have expanded to a benthic cyanobacteria monitoring program in the creeks. So we just wanted to talk about that a little bit, just an overview of this project. So we did receive funding from the Public Health Institute, in particular, Tracking California program, to be looking at cyanotoxins, benthic cyanotoxins, and cyanobacteria in the creeks of Lake County. There are many creeks. They're actually in multiple watersheds, and so we have been building the program in the last couple of years, continue to refine it, and we see it as a way to get additional information about cyanotoxins in locations that are being used by people and animals, and for traditional cultural activities of the tribes, as well as just recreation and even drinking water. The The program itself has a combination of spat bag installation as well as grab samples for toxin analysis. And there's additional information as well that we're going to go over just shortly. We have experimented with leaving the spat bags out for varying degrees of time, and even in the beginning, we're leaving it out for up to a month. And that was, we did check in with kind of all of the groups that are doing spat bag, using spat bags in their monitoring programs, and that's why we started with why we've made some changes, but we're now down to about leaving spat bags out to about a week. We are doing toxin analysis based on the cyanobacteria that we're seeing that's present. However, because of the funding, we have been able to test for all 4 toxins, total microcystin and others, including and sometimes doing the qPCR for gene copy counts of the cyanobacteria, or gene copy counts of the different types of toxins. We, of course, because there's so many creeks and some of these are on private properties, we did first start out with doing a map overlay of all of the different creeks and then where the public roads are, and then also looking for bridges or places where we could, have easy access. Some of the locations had some really steep, craggy, very difficult ways to get down to the water. So we basically cut those out and don't sample on those types of locations. We're looking for safe locations to install these spat bags and to do the grab sampling. And then we also look for, in terms of the monitoring locations, look for evidence of human or animal access and use. The data collected per site. So we have a spreadsheet where we're collecting this information. Currently, we have not, we're in the process of being able to submit qPCR, gene copy count data to the Water Quality Exchange. Because we're a tribal program and federally funded in most of our programs, we submit to, to the federal databases. And in this case, we have been sending off toxin analysis. But in terms of what we're collecting, we do a grab sample. Kind of our process is we do a grab sample, basically a baseline at the sites where we're going to be monitoring, and send off for all 4 toxins. And we do that when we do the spat bag install. And then if we get toxins through the spat analysis as well as the grab sample, we will do a second spat bag install, but not necessarily a second grab sample. So, just because of funding, we definitely want to get a point in time what the toxins are, but also through the spat bag, which is of course getting like a cumulative dissolved toxins that are building up in the bag itself. We do a visual assessment of benthic cyanobacteria cover and track that, photos of the site, habitat information, microscopy of the grab sample, velocity, and water chemistry. So this is all information we're collecting. And then so in our last 2 years, these are the sites that we've monitored in Lake County. As I said, it's multiple watersheds. We do have some sites where that are tribally important. So and we talk to the tribes about spots that they want us to check. But in general, these meet the qualifications of being safe locations that have public access. Alex, did you want to say anything about this slide? Want to bring
No,
it in?
it's bunched up. I wish it was a little bit blown out, but yeah, this kind of says it all. We've done a lot of lakes, or a lot of the creeks around Lake County. It's as you can see, though, Nice Lucerne area is pretty bare. There's not much creek action going on. I think there's one creek that flows into Clear Lake, but it's so ephemeral that it's hard to catch.
Exactly. And it has been difficult to know when to when to install the spat bags. We're not trying to get it in the beginning of the season necessarily, or definitely don't want it at the end of the season, because you can't let the spat bags go dry. We've also had some spat bags vandalized and just completely disappear. So we're just trying to find that kind of the best time to when there's a certain amount of flow, and and water in the creeks, and some of them go down quite a bit. So the next slide, we're actually Alex is going to talk about the how she makes the spat bags. Of course, we found out that Ben Genetics sells them, so we might be doing that more. But anyway, we have a process. Go ahead.
Yeah, at the beginning, I reached out to Ben Genetics, and at that time, a few years ago, he wasn't making spat bags in his lab, but now they are. So with that, I spoke with Jamie and from Squirp, and so we followed their standard operating procedures on how to make a spat bag. They had two different ones. We followed this heat sealer one, as you can see on the left-hand side, those steps. So we purchased all of the supplies needed, the di-ion resin, the methanol, the DI water. We also had to buy the impulse heat sealer to seal all these things up. And I was in constant contact with Jamie, kind of asking questions along the way. She's been so helpful. That was really amazing. So these were even the first round were pretty successful spat bag making. So this is on the bottom, this is what a typical setup looks like. In our creek, this is Dry Creek in Middletown, just an example. We try to place so we install a T-post, and then the spat bag goes inside of like an open mesh kind of laundry bag that you'd find at like the Dollar Tree. And then we would zip tie that on to the very bottom of the T-post closest to the floor, the creek bed. And like Sarah said, after a week, well, we started off doing 2 weeks, then some of them went into a month, but now we're down to, about a week. It stays in the creek. There's some new information that came out from FHAB about if you leave the spat bags in too long, they tend to have a lot of biofilm. And then also if we get some kind of heavy rain that washes a lot of water through, it'll wash out all of the absorbed cyanotoxins in that bag. So definitely trying to stick with a week in there. Next slide. Like Sarah mentioned before, we take microscopy. We do microscopy at each site that we monitor. So as you can see, we found various cyanobacteria, but these are probably the most abundant. So Nostoc at Manning Creek, we found Nostoc at other creeks, but it seems to be pretty consistent at Manning Creek. We have a few sites on Manning Creek, so this is actually our furthest upstream site has this Nostoc. We've been seeing Formidium for a few years now at Seasonal Creek, and it's interesting because it doesn't necessarily grow on the creek bed, but because the Seasonal Creek is a tributary of Manning Creek, there is a cement sort of bridge that connects this tributary to Manning Creek, and the Formidium actually grows on that bed of the concrete and then ends up growing in the creek bed itself. This is Raphidiopsis down on the left in Scotts Creek and Middle Creek confluence. It's a very interesting site. There's a lot of cyanobacteria here. And we do have a site that we've tested upstream on Scotts, and we've also tested multiple sites upstream of on Middle Creek, but this is a very interesting site at the confluence. And then we also found some different species of benthic anabina. We haven't keyed it out all the way, and this one was specifically in Kelsey Creek.
And these sample photos are from the grab samples that are done along with the installation of the spat bags. So, Alex, do you want to talk about how you get grab samples?
Yeah, so when we install our spat bag, and at that same time in that same area, I'll get a grab sample. And then I'll freeze it back at the office to wait for the spat bag to come back with toxin. We have to collect the spat bag and then send it off, wait for the analysis. And if the analysis comes back with detects of any toxin, we'll send off that grab sample for the detects that spat bag came back with. So for example, I'm pretty sure that St. Helena Creek, you'll see at the very end, kind of the data analysis we've done. And St. Helena Creek seems to have high amounts of microcystis and antitoxin. And so we've sent off the grab samples from that spat bag for antitoxin and microcystin. Tried to focus, like Sarah mentioned before, we have little, not a whole bunch of funding, so we have to really think about how we're going to send these samples off.
Thank you.
Next slide.
So our data summary, so 14 sites were sampled, 14 creek sites were sampled using spat bags, the baseline grab samples that Alex was talking about. The highest detect of microcystin at the baseline of the first installation was at the caution level, 1.78 micrograms per liter. However, there were antitoxin hits, and those were at 130 micrograms per liter. And the grab samples include the mat, so it's and of course during the analysis there's a lysing of the cells, and so they're able to get the toxins that are normally within intracellular in the cyanobacteria cells. So, basically we are seeing, just as kind of what's been mentioned in earlier presentations, every creek is kind of different in terms of what we're seeing and toxin levels. We are seeing toxins in the creeks that we are not seeing in the lake. In the lake, we do toxin analysis, but we also do qPCR to look for gene copy counts. And in many cases, in every case, when we're looking for cylindrospermopsin in the lake, it's always come back non-detect, and yet we see cylindrospermopsin in the creeks that flow to the lake. Same with saxitoxin. We've seen very low levels. We've seen saxitoxin gene copies in Clear Lake. I believe maybe a low toxin detect of saxitoxin, but we have seen saxitoxin in several sampling events over the last couple of years in the creeks. So what we're seeing in the creeks isn't necessarily in the lake. And as Alex said, we do have a process where we are basically doing a second grab sample if the spat bag analysis comes back with toxin detects. Again, it's a cumulative of what is toxins that are dissolved. So it's really a sense of giving you what's being produced in those creeks. And of course, because there's human and animal use, we are interested in what those results are. And frankly, the way that we use the data, we're still working on the logistics of having like a really fine-tuned way of communication, because it is very different from our lake sampling program that has been ongoing for 11 years now. I guess we're getting into our 12th year, and this program just started. But because we are doing tap water testing of homes that get their water from creeks and the lake, as well as having nearshore wells, this information has come in handy, and the ability to do benthic toxin analysis in the creeks has been helpful, because we've been also able to do some where we've been doing tap water testing of homes that are nearby, and have also seen some there have been some homes that have had I believe have had toxins in the creeks, and we've seen cyanobacteria in their tap water. So the benthic program is a way for us to have an increased understanding of cyanobacteria and cyanotoxins in the whole, in multiple watersheds in our area. And that, along with fish tissue cyanotoxin analysis that we're doing, is just giving us really good picture of the different ways that people could become exposed to cyanotoxins through recreation or drinking water and some of the other beneficial uses. You can find more about our tap water program at the URL that's on this screen. And other than that, we want to thank you for listening, and appreciate the other presentations on the benthic programs as well. Thank you.
Thank you so much. So we will adjourn for lunch now. We have more content when we're back. We're going to have some subcommittee updates. In particular, we're going to have benthic CCHAB work group is going to come and go over their product that they have created and the review edits that have come into them, and we're going to go through those. So I'll see you all back at 12:40, and enjoy your lunch until then. Thanks.
I hope everybody had a delicious lunch. I'm going to be hosting the second half of today's meeting. So thank you, Karen, for doing the first half. We have a subgroup focused agenda for the second half of our winter meeting today. And so I'm really pleased to start with some updates from some of our current working groups and affiliated working groups. So let's go ahead and start with Shannon, who's going to kind of give us an update of the illness work group. So Shannon, you got your slides up. I'll hand it over to you.
Great. Thank you so much, everyone, and for the opportunity to give you an update. So we just finished our 2024 year, and we don't have all the final details for all the HAB-associated illnesses that we reported to CDC's One Health harmful algal bloom system, but I can give you a few highlights from last year and the number of cases that we have. Just want to acknowledge my partners. This is a 4-agency work group. So we have Carly and Marissa, with whom you're very familiar from Water Board, Thomas Hayashi from CDPH, Becky and myself from OWIHA, and then of course, one of your hosts, Karen Odkins from CDFW. Just a quick overview of the number of cases. A couple things to keep in mind. The number of reports that come to the illness work group may be significantly more than what ends up being determined to be HAB associated per the CDC OHAB's criteria. But ultimately, this is what we reported for this year. So on the freshwater side, we had a total of 25 reported cases, 25 individuals, and in some cases there were groups of 4 to 6 that were associated with a singular case. So we had 25 individual humans. This is all from water contact or proximity to a water body. For example, they could have been shoreside and had potential impacts from respiratory exposure from water particles containing cyanobacteria or cyanotoxins. So their illnesses range from gastrointestinal symptoms to respiratory to dermal skin contact illnesses. We had a single dog report for GI illness. We had 15 group events for fish, representing more than 49,000 individual fishes that were represented not only in illness in some cases, but mass mortality events. And then one wildlife and bird group event that involved 4 individual waterfowl mortalities. And then on the marine side, we had a total of 49 cases. 2 of them were for 2 human individuals, respiratory and dermal complaints. And then unfortunately, again, this year, we had significant impacts from domoic acid toxicosis related strandings with ranging with symptoms of the neurological nature, gastrointestinal, and in many cases, unfortunately, death. And those were either found dead upon reporting of our marine mammal agencies for the stranding network, or they were taken into care at one of the marine mammal care centers and then subsequently died or were euthanized. So we had 392 individuals, the majority of which were California sea lions. We had 15 northern fur seals and then 4 dolphins. So not the 1,100 that we saw last year, which was really on record catastrophic, but certainly a big concern. We do anticipate that a handful of more cases might be coming in for November and December. 7 coastal counties reported impacts, and so that is what is represented in these cases here. Just because we have our all of our 9 regions here represented, I thought it might be interesting to know that the bulk of the cases for 2024 were represented by Region 6 and Region 5. A handful of cases here, Region 2 had, or 3 had 2, Region 4 had 1, Region 1 had 1, and Region 9 had 1. And then for Regions 2, 8, and 7, no HAB associated illnesses were determined and subsequently reported to OHABs. Couple things I want people to keep in mind. Just because HAB-associated illnesses were not reported for your region does not mean, of course, that you did not have HAB events. And in fact, many of these regions, as was given the reports this morning, reported significant HAB events, some often enduring through the entire summer months, and certainly at caution and all the way through danger levels. So perhaps the constant monitoring for some of the efforts, the pre-holidays assessments, the increased communication and outreach engagement with yourselves as the region coordinators, as well as your partners. Really, hopefully that was all leading to good communication. The public was making more informed choices and were then not exposing themselves to potential illnesses associated with a HAB. There are a couple other findings that we encounter, although less frequently so, is that there might be an illness reported following water contact where there is a confirmed HAB, but the illness ends up being attributed to another cause, for example, a communicable illness like COVID, or some sort of other allergic type event that's not associated with the HAB. In some cases, there's insufficient evidence to link the confirmed illness, meaning it was an actual illness, but not necessarily confirming it in any context that we could relate it to a HAB event. So that can happen. And then in rare cases, the reporting party, whether it comes through the HABs portal or some other conduit, such as poison control, the reporting party fails to leave their contact information. And so there's no way that we're able to follow up to even pursue the investigation other than maybe contact our regional managers, see if we can get at least a visual site visit if that's convenient and feasible. But again, just wanted to acknowledge our partners in Region 5 and Region 6, where those two regions alone represented 89% of the cases that we were determining to be HAB associated per CDC criteria. So thank you so much. It's really a lift that we could not do without our partnerships there, including Big Valley Rancheria for Clear Lake cases in particular. And a couple highlights, we've really made an effort to do our outreach and engagement as a work group this year. So as per usual, every late winter and early spring, we update our websites and associated fact sheets in both English and Spanish with all of our new numbers. So we have updated through 2023 currently, and then we will be in the process shortly in updating 2024. We did some particular outreach in supporting the public health departments for Los Angeles and Lake counties this year. We addressed at least 3 or 4 university and professional student inquiries ranging from nursing students to undergrads doing pilot projects associated with HAB interests. We participate in the monthly CDC OHABs community of practice calls. And then a particular acknowledgement for the hard work from our CCHAB coordinators last quarter for doing a wildlife and fish focused meeting. We were able to be in contact with the West Coast Region Stranding Network point of contact from NOAA at that particular call, Justin Greenman. And it was through that direct CCHAB connection that we were able to get those verified numbers for the marine mammal strandings that occurred on the coast of California for 2024. So thank you so much. CCHAB really has an extensive reach, and we're grateful for that. Creates more work, but there we are. And then, of course, some training webinars and presentations, including CDPH One Health Symposium, the Health Officers Association of California, North American Lake Management, and then, of course, the really fantastic multiple-day Clear Lake Integrated Science Symposium, where we were able to present our work specific to Clear Lake. And that is what I have. Thank you so much.
Great. Thank you so much, Shannon. Let me look. We have on our agenda next is Hugh, who would be providing an update for the mitigation subcommittee. But I don't see Hugh Dalton on the line. So let me just double check. And then Hugh, are you on? And you're under a different name, maybe? No. Okay. So since Hugh, we don't see Hugh on, and then Karen, if you see him or anything, just give me a shout.
Yeah,
I
I'll
think
send him an email really fast too.
okay. Because we can go ahead and move on to the Benthic HABs working group. We have a I'll go ahead and throw my camera on so you don't have a black screen. We have an exciting kind of a unrolling of our products. And so I would invite Carly, Marissa, and Mike to join, and we can go ahead and get our slide deck queued up. And then we'll just get a little extra time for our presentation. But Marissa's gonna start us off or not Marissa, I'm sorry, Carly's gonna start us off and kind of introduce the product, some of the products, and then we'll kind of as a team go through the various products that this working group has produced and what was reviewed and kind of what we would like to propose to the CCHABS group as the next steps. So Carly.
Yeah, can you hear me? Am I good?
Can hear you.
All right, can you see my screen?
We can see your screen.
All right, rad. Okay. So I'm Carly and I'm gonna get us started. I work with the State Water Resources Control Board, but this was a definite team effort. So you're gonna get to hear from all of our co-leads today. And I hope a lot of the folks that helped contribute to this working group over the couple years are still on so they can get shout outs throughout the whole presentation for all of their guidance and direction. So first, I just want to discuss why we reconvened the benthic subcommittee. As you learned from some of the earlier presentations that cued this really nicely, HABs are a growing benthic HABs especially are a growing field of knowledge. So we really wanted to evaluate our current CCHAB guidance for our public health advisories for benthic harmful cyanobacterial blooms, and then also reevaluate if that recommended signage is incorporating that newest science in those recommendations, and then determine if we should be providing updates to those recommendations for monitoring and the associated advisory. So those were the main components of it. As before, this is the first shout out, but I'm sure there's going to be many more. We are really lucky to garner an amazing group of folks and experts to join the subcommittee. A list of the organizations are here, but they're a wealth of knowledge, and it was such a pleasure to get the opportunity to work amongst them and to gain a lot and glean a lot of their knowledge base as well. And you see a few of our previous presenters were part of that as well. So just to kind of give you a timeline, this hasn't been an overnight project. We convened the benthic subcommittee in May of 2023. We had regular meetings for about a year and a half. Obviously, summer season can kind of stall things out a bit, but during that time, we worked through a lot of different components, which we're going to discuss later in this presentation with you. And then in early December, we solicited review and comments from folks from the CCHAB community on these products. And then what we're doing today is we're giving you a brief rundown of all the products and all the comments we received and how we incorporated them into updates of the documents. So just giving you another glimpse of what we received in terms of comments. We had a total of 16 reviewers. We had a form that folks could use. We also had the opportunity to provide comments directly in the documents. So we had a ton of reviewers. And so from here, we're going to summarize the documents and then provide some of the, not all of the comments we received, but a lot of the general comments and some of the themes, and then some of the updates we then did. So I'm going to start us off with the first document. This is our benthic harmful cyanobacteria bloom guidance, and this was sort of the driving force for all of the supporting documents that some of my colleagues will be going over in a moment, but we'll start with the guidance. So I mostly just want to highlight what the purpose of the guidance was. We specifically wanted to address monitoring guidance to assess the potential risks that the benthic HCBs pose to health of humans and domestic animals. So we weren't looking at aquatic life or ecological health. It's really for that human health and domestic animal health. And we focused it on loadic systems, although we did have some caveats in the SOP, so things could be amended and applied to lakes and reservoirs, but the primary focus of this really was those free-flowing systems. And then as well, it cataloged a rationale for the supporting documents. So we had definitions of the different monitoring types that we were considering, the indicators and methods, and then the different monitoring options associated with different advisory signage. And I'm going to get into all of that in a minute, so bear with me. So once again, just want to reiterate the overarching guidance question was, should human use or domestic animal use be restricted in a water body due to the presence of benthic HABs? And then, as I said, we expanded the goals to look at different types of monitoring. So whether that's that immediate event response, which happens most often for us in California, where we get told that either the public saw something or there was a potential illness, as our illness work group member Shannon just kind of mentioned. And then we go up and do some additional follow-up monitoring. And that will then drive whether we recommend advisory signage of that water body. The other types of monitoring is the follow-up monitoring during the entire HAB season. So like from when we received the event to that follow-up monitoring until it senesces, to provide that public guidance throughout that entire HAB. And then as well as routine monitoring, which Region 1 has been a really great model of monitoring before the HAB begins, so they can start doing that public messaging when the HAB forms and then during the bloom season. Through that, as mentioned, the benthic HAB realm is still a work in progress in terms of our knowledge base. So we did an extensive literature review, and then we looked at different indicators to be considered with this guidance, including coverage, cyanobacteria, and toxins. And then because, of course, we couldn't make it simple because it is such a complicated topic and there are so many different types of cyanobacteria to consider and they all behave differently, and we had to have a guidance that would be most approachable for all the different types of scenarios. We did a grab bag approach. So I'm not going to go over this too much because I feel like I sort of went through it enough in the last slide, but just kind of highlighting again the different types of monitoring, event response. The assumption is that there wouldn't be any additional monitoring after that initial response. And then with the follow-up monitoring and the routine monitoring, there would be routine monitoring throughout the rest of the HAB expected. And so the different types of monitoring then trigger the different decision points for posting and deposting and the different advisory level. As before mentioned, we looked at a lot of different indicators. You see the green circled ones, these are the ones that we decided to focus on. So percent cyanobacterial coverage throughout the reach, as well as looking at microscopy. Microscopy was also evaluated, and that is also a component of our field data sheet. I probably should have circled that one. As well as the different toxins. So the toxins we were really examining for determining how to advise public recreation and public health was looking at the spats, and as well as doing either ELISA or LCMS. So this is a lot to look at, and I'm not going to go too in depth, but I am going to do kind of a cursory walkthrough with you. So this is the flowchart of how an event response monitoring may occur, and you'll notice that there's different types of monitoring here we have evaluated. So first of all, you get notified of a HAB event. You do a visual assessment. If you don't see any visual triggers, some folks, we get a lot of people that notify us because it's actually green algae in the water body. So if we have experienced folks out there, they can help identify through the macro, like, visual observations, what is present. If a HAB is present, then we recommend doing a coverage assessment. And Marissa's going to go more into our standard operating procedures of how you go about doing this. So hang with us for a little bit. There's a lot to cover here. So if there's over 15% coverage, then we recommend doing follow-up monitoring, which that goes into a lot of the components that are very similar with that routine monitoring, which I'll get into in the next slide. But a lot of that is doing coverage assessment, collecting composite mat samples to figure out what toxins are there and at what concentrations. And then as well as depending on the water body, as mentioned before, it can be very variable, even in a single river in terms of the coverage and what toxins are present. So we do recommend deploying spats, as well as collecting cyanobacteria samples for taxonomy. And that's mostly just knowing what's in that river system so we can do more catered monitoring in the future, specific to that water body. And then if toxins are over 15%, we definitely recommend collecting samples for ID and toxins. And then deposting at the end of the recreation season. If you're doing that continued monitoring, then we recommend 2 consecutive sampling events with no visual observations or no toxins present to go ahead and depost. And then with this, the table over here, this is the signage recommendations, and they are different. I do want to highlight that for event response, and then with the follow-up monitoring and the routine monitoring. And the reason for that is for this initial event response, we assume there is no follow-up monitoring, so it's a lot more conservative in the approach we have for messaging for the public. So next, I'm going to go over routine monitoring. And once again, when I talk about a grab bag approach, I wasn't kidding. So we have 2 different types of approaches, realizing that cost can be a factor, and any data is really great data, especially for understanding trends on an interannual basis and an annual basis. So one approach is if you only have the field personnel but you don't have the lab budget, you could do visual monitoring. Or you could do visual and toxin monitoring. So we recommend the SPATs as that early detection. We don't necessarily recommend we really focus on the % coverage for determining that signage recommendations for the routine monitoring. As you may notice, it's very similar for the routine monitoring as that follow-up monitoring. It follows that same schematic. And this is this over here is the table that corresponds with the follow-up monitoring and the routine monitoring. So some things that you might notice is that if toxins are detected, we recommend green signage if the toxins are at a low concentration, whereas with the event response, we recommend immediately the yellow signage because we assume there's not going to be any follow-up monitoring. But they follow the same schematic where high % coverage always will trigger that yellow sign. And if you're not familiar with the signage, we will be going over that later on. So now I'm going to go over everyone's most favorite part, the comments. So we kind of have them broken out by theme and the comment and then how we address them. I'm going to go over it a little somewhat briefly just because we have a lot to cover and I want, in the interest of time, to get you out on time. So we had some clarity questions as to what specifically this guidance applied to. As you may recollect at the beginning, I highlighted that it was really for public health messaging, for domestic animals and human health, as well as focusing on those flowing systems. So we definitely added additional language, the overview section, as well as a table. And then for consistency of terminology, that was a great comment because as we all know, there's benthic and planktonic HABs. So we made sure to be consistent so that folks were aware that that was the focus of this guidance document. And then for requested change for signage recommendations, so we did add for even if there's low % coverage, we added a threshold for if there was high toxins detected in the benthic mats. And because we don't have any benthic thresholds, we actually just we went with something we know. We went with the planktonic warning trigger levels. So even if there's low coverage and so there's likely low deliverability, if there was really high toxins present in those low coverage assessments, then we still recommended having the yellow alert sign if we had the high toxin concentrations. We had some comments on clarification, so especially in our indicators and methods, which you may recognize as change. It was originally metrics, and we got a really great suggestion that these really are methods, so it might be more applicable language. So we went ahead and changed that. Some questions just on terminology in terms of we were somewhat using DNA and qPCR interchangeably. So we just made sure that that was really clear so that the reader didn't make any misinterpretations. We added additional language. We got a lot of comments on different strengths, weaknesses, and potential applications of our indicators and methods. And it was really great input, especially from you folks that are out in the field. So we added all those in. And then as well as separating out ELISA and the LCMS-MS. And so we went ahead and broke those out. That was another great suggestion. And then there was some comments about how we were using spats as an early detection method for the increasing benthic HCBs. And so we definitely added some more language directly into the guidance document, pulling directly from the North Coast benthic thresholds memo, just to be consistent and to add in a little bit more robustness so folks didn't have to go and reference that as well. Some more clarifications as to monitoring. So the flow chart was really confusing to folks. We also had the signage recommendations in there. So we broke those out. We created separate corresponding tables in the document and then an overarching table as an appendix, which folks really did like. So we made sure to keep that. And then we had a request to better define the end of the recreation season. So we provided some additional examples, whether it's a recreational season closure or winter conditions may prevent access or limit recreation, or if the river was frozen, and or if winter flushing flows had already occurred. And then more consistency of language. And change percentage cover, that was a really good suggestion. We had it less than and equal to. We changed it to less than 15 because obviously you don't want less than and equal to and greater than and equal to together, because then it's hard to differentiate. And then made sure that we were just really clear when we were talking about toxins, we were talking about spats, benthic mats, or both. Some additions and recommendations. We added a glossary just for acronyms. That was a great suggestion. Those of us who work in California are really familiar with those, but other folks who may be reading this document for the first time may not be, so that was a great suggestion. We added some clarifications as to understanding the SPAT thresholds that inform advisory signage, and that was generally speaking to referencing the North Coast memo once again. So we incorporated a new table that Mike added into that thresholds memo to make sure there was consistency and that the reader didn't have to comb through the document to find it. And once again, we removed the signage recommendations. We added additional information. There was some questions as to cost for the different indicators and methods. So we put in some references to the ITRC, which their website, if you're familiar with, has a great breakdown on different analyses and the costs associated with that. So we referenced that so the reader had that as a resource. And then some comments we received that we didn't actually incorporate because of other reasons. Is we had a request to define recreational sites. And that's actually under the purview of the California Water Quality Monitoring Council. They're now mandated to determine what an inland recreational site is. So we're going to leave that one to them. And then as well as changing our sign tiers. So for this project, it was more determining the monitoring and the guidance to correspond to those signs, but because we don't have thresholds, I don't think the intention was never to change our signs. So that's something we can look at a later time. When we get more information on benthic halves, if we get thresholds, we consider this sort of a living document at this time, incorporating the newest science. So we can pivot at a later time. We just don't really have the information to make some of those changes at the moment. And with that, I'm going to pass it on to Marissa to talk about standard collection procedures.
Yeah, thanks, Carly. I was watching the chat. I didn't see any new chats messages, but we'll be watching it along with the larger team that's presenting. So yeah, I'm going to go over a second piece of the documentation that was circulated to review to the entire CCHAB network. And that's the standard collection procedure for collecting visual observations of benthics in the waterway and collecting mat sample as well. So the standard collection procedure has many sections that they're listed here, beginning with a new section, constraints. So what influenced the design of the procedure. That was a significant area of comments. And then it goes through other common sections that you see in procedures, equipment and supplies. It has a short overview of all the procedures, and then now we have a handout as well. And then it goes through the process that you do in field, then sample handling, shipping, cleaning your equipment if you use any, and then how to communicate with the laboratory on what kind of analysis you want to inform, based off the guidance that Carly just presented, and reporting. One thing I wanted to highlight with this SOP, what influenced the design. We all wanted a standardized procedure on how to get the data to inform the advisory posting decisions. And that's its intent. So it's a rapid assessment procedure. It wasn't intended to be, comprehensive ambient monitoring procedure, or, to look at the ecology, that kind of thing. It has quite a narrow scope. And with that, to meet the community needs of CCHAB network that we've heard, over the years, especially since the first iteration of benthic guidance came out in 2020, that folks really wanted something that was, didn't require advanced water quality technology, and was kind of like something that can be implemented low resource, considering we're in this environment of voluntary guidance in the state. Okay, next slide. All right, so this is an overview of the procedure's options. So we have different options depending on the water body type. The procedure is focused on the primary waterways that we do assess for benthics. So flowing channels, which are streams, rivers, and then we did make a modification for lakes and reservoirs to focus on assessing the shoreline and then that nearby water that comes to the shore. Most often targeting beaches. And then based again on community feedback, there is a need to do a shoreline only procedure to visually assess benthic growth without getting in the water. And that was due to, low resources for field supplies, or not having the authorization to go into the water for some entities that do that they have participated in trainings in the past for event response, but need a process that they can do from the shoreline. Next slide. Okay, so with these procedures, there's a process to define your sampling area. So sample area is approximately 150 feet in length. So length of a channel or length of beach on a lake. Much of our figures are based off of a channel, just because that's the most commonly assessed waterway in California for benthics, just to keep that simple. The process is to set your site, then walk it to survey what kind of potential cyanobacteria growth is present. We have a custom visual guide to help folks calibrate their eye on what they're looking at to differentiate between filamentous algae and other similar looking growth. And we also have a lengthier visual guide as well, which we'll have links to. And so after doing that walkthrough, we recommend looking for patterns of growth, visual hazards of benthics. So that's really dense cyanobacteria benthic growth that could be detaching or already detached mats that are floating by you or accumulating in your sampling area. And then we get to estimating percent cover. So as that channel is assessed, it can be quite a long length, especially if you have like cobble and sand and a wide channel. So we have a few different approaches here. On the left, this is the shoreline only survey. So on the left, you see like a dotted line, or sorry, dashed line with some dots. That's presenting like the person stopping at incremental points and viewing from the shore into the water to do that visual assessment. And then there's like in the flowing stream, we're marking, an area where there might be a riffle, and then slower moving water with those cobbles. Then the middle part B is representing, if one staff is visually assessing the stream. Okay. If one staff's visually assessing the stream, we would recommend going in a zigzag pattern just so you can cover all the area as best as you can, looking for those patterns of growth and visual hazards. And then if you have two staff, we recommend taking one side of the channel and doing that same pattern. And while you do that, it's sometimes we found it easier just to kind of mark off the area into thirds. So what you see, like your largest size class of benthic growth, for each third, you can mark that down on your field data sheet, and then after you assess the whole area, then you would determine what is the greatest percent coverage that you visually assessed, both in the flowing water and any riffles in your sampling area. And that was just a quick walkthrough of how to do that for the channels. Next slide. And with the procedure, we have an attachment that a full page attachment to show you kind of like a schema on estimating percent cover from 2% to 75%. Even though our categories are broader, just helps train the eye on like different patterns that you could see. And also we have another diagram that shows, how benthics can appear in channels in California. It can be dispersed throughout your sample area, pretty, spread out evenly, and is marking that 1/3 separation, just to help eyeball your visual estimates, breaking up your sampling area into thirds. And then sometimes we do find that there's really patchy growth. Maybe there's just one large patch in your sample area, or two large patches. So we're just kind of like presenting, the different growth patterns that we see. Next slide. All right. And so with those options for the procedures, we also asked, then for collection of a composite sample. If you see the visual growth, then you would then go to the next step for composite sample collection. And when you're in the water doing that option of the procedure, you're doing a combination of assessing the in-stream and the shoreline area. And you're looking for 2 hotspots, so of areas of the most growth in the water, and separately 2 hotspots along the shoreline. That's depicted on the right there. And then you would take pieces, pinches of about 3 square centimeters pieces, and put them in your sample container. So 3 per hotspot. We got to 12 total pieces going in that sample container. And some people, feel comfortable taking pinches of benthic mats with a gloved hand in the water, but folks can scrape off what they find, put it in a bin, and take it to the shoreline, and then replicate that procedure. So each piece is approximately the size of a quarter coin, to give another reference there. Then the out of water sample is just the shoreline. Just wanted to highlight that. That was the left figure. Go ahead, next slide. All right, now we get into comments that we received. And really, thank you everyone for taking such a thorough review of the procedures. Really goes to really improving that so that it can be utilized by a broad range of entities. Really appreciate that. So just going through the comments kind of in the similar schema that Carly presented them. We try to highlight all the major subjects that were commented on, and then wanted to really focus on that and left kind of like more of the editorial comments to the end of this slide deck. So let's start with some general comment themes. So we heard from you that you'd like to see expanded background and education to inform users that are new to benthic HCBs. So we added subsections, intros into each kind of section of the procedure that provides additional references for users to go read for more background information. And then some terminology that we kept on repeating. We also put footnotes just to define that or give examples right into the text, so you don't have to go to a separate glossary, particularly if you print that out separately. And then another general feedback was that we needed clarity on the purpose of the procedure and why there's different options. It struck some folks strange that there was a non-weighting option. So we went a little bit more into the purpose, again, of the procedure to being a rapid assessment approach to get the data to inform posting advisories based off of the guidance that is proposed in the document Carly just went over. So it's not ambient monitoring to represent the conditions of an entire segment of channels or an entire lake. Unfortunately, we couldn't go to that purpose. we kept it very narrow for the purposes of the guidance to inform advisories. And based off of community feedback, there was a need to do a non-weighting option, as I did describe. So we made that really clear, and some other constraints in a new section that actually goes into design considerations and why we went in a certain direction, again, based off of CCHAB community. So there's other comments on, again, clarification on the procedure for kind of like the technology, the water quality technology choices. Many of you had recommended the use of adding PVC constructed quadrats to help estimate the coverage assessment, to make it more of a quantitative approach than qualitative, not just using our eyes. And we appreciate that feedback, and we are really aware of how useful those are in some other procedures that are in development for benthics. We just weren't able to incorporate that because of the constraints of our design based off of community feedback. So we focused on having no water quality monitoring technology and low cost field equipment. Again, to inform advisories, we're working in a voluntary environment. So we have to work with those constraints. Another feedback was developing a standalone summary of the procedure, so folks don't have to take this 7-page document with them in the field if they just want to have like a 1-pager for reference. We wanted to put the diagrams in, so we made a 2-pager, and that is shown on the next slide. We just have a snapshot. So we did make a 2-pager, and it's an attachment. So folks can take that out as easy reference, have it on their clipboard. To walk them through each option, and then how to visually survey that sampling area, considering that you're doing visual estimates. It's like more of a qualitative approach. All right, next slide. Continuing on with comments, we had another clarification for the procedure steps, just like how to start that process. So we included another section for site selection that goes over how to select the sampling area, considerations for that site, and how to do some space for desktop recon, particularly if you aren't triggered to do this because of a public complaint that there's potential HABs. If you're doing proactive, has a little bit of information on that kind of step into the procedure. There was a request for an additional diagram to showcase how shoreline survey would be done, and we added that to figure 3, which we already highlighted in the slides. So thanks everyone for feedback. We clarified percent coverage estimates. So folks wanted to understand a little bit more about how do you estimate the coverage for when benthics are growing laterally in some unusual kind of patterns and density and towers, how to consider the vertical growth when we're actually asking you to do the lateral growth, right? Percent coverage is over, or like the flat area. So we included some more examples to walk folks through that and to calibrate their eyes to do this coverage assessment. We also expand a little bit more about visual hazards of benthics. Why are these hazardous? How are these counted or measured? So we defined some of the terms and gave a little bit more background on why these are a particular concern. That increases exposure to particularly children and dogs when benthic mats detach, they're floating, they can accumulate on shorelines and slow moving areas, and then how it looks like when they're about to detach, when they're coming apart. Next slide. All right, we had a few more clarifications, including the ponded water body option. We broke that out in a whole separate option, separate from channels, so there's less of a confusion. Try to clarify that. Hope that helps. We circulated that amongst our group to see how that flows, and it seems much more clear. And also the process to assess your beach for lake, we provide additional instructions on how to prioritize your sampling area and which direction to walking towards the windward side, depending on the current site conditions. And then the field data sheet is a key component of this procedure. And that wasn't, how you do your data entry wasn't entirely clear with the process. So we brought the information that we had in the attachment that had snapshots of the field data sheet in each section kind of blown up for you. We integrate that into the procedure so users can see right away, oh, this step, now I do field entry, and the next step, then there's another section, and walks folks through in a more step-by-step process. We got several comments requesting that kind of walkthrough, so we added that. We made a mistake on the sample storage temperature, so we made that consistent. And lastly, there's several edits for clarity and improving grammar. So we did accept comments, suggestions for improving clarity. If it didn't add more additional technical terms, we're trying to keep it a little bit more simple in our terminology that we use. And then generally, most of the grammar suggestions were also accepted. I wanted to give everyone a heads up. All the documents that we prepared, they hadn't gone through professional editorial review until they're near finals. So that will be a step that we'll do before providing it to CCHAB co-chairs for posting on that kind of thing. So next slide. All right, I'm gonna hand it off to Mike, who's gonna walk us through the field data sheet.
Thanks, Marissa. So yeah, I'm just gonna quickly go over the field data sheet. Next slide, please. So there's a lot going on here on this slide, but what I want to touch on first is basically the field data sheet was designed to walk you through the SOP process that Marissa just described. So hopefully, the questions asked and the descriptions therein will kind of guide you through the process should you not be able to reference the SOP in the field. So just kind of going over different sections at the top there, not in the square or in a red box. It's just your general site information and what kind of monitoring is being conducted. And then in that first red box there, just recording what kind of coverage is being assessed. Are you getting in the water, or are you doing a shoreline assessment? And then moving down to boxes kind of 2 and 3 there, just what kind of cyanobacteria are present, where are they located in the channel. Next, just if there's any visual hazards that are present, we're particularly interested in these because that, of course, is when risk or exposure potential increases, and how cyanobacteria are distributed, how big mat patches are, and then referring to that percent cover diagram to kind of check off what the coverage would be falling into those kind of 4 categories. And then getting down to the 5, 6, and 7 boxes, just recording information on the types of samples that are being collected, and if known, what kind of analyses will be requested, etc. And then at the very bottom, just any other ancillary data like water quality, phys chem information, and additional notes. Okay, next slide, please. And yeah, just highlighting this percent cover diagram again. I think Marissa touched on it pretty nicely. It's ranging from 2 to 75%. And it's really just to kind of dial you in on what you may be seeing. Of course, we're most interested in that 15%. Oh, yeah, 15%, which is actually a lot more than you think it would be. So it's good to kind of gauge your eyes here. Next slide, please. So just some comments on the field data sheets that we got. Just a handful, really. Some text revisions and terminology. For instance, like replacing the term genera with taxa, removing certain units for water quality measurements. We did get a request to add a new data field for like including the deployment length for SPATs. So that was added to this field data sheet. And then there were some comments about, there may not be enough space to add information, or you may want to elaborate, and we totally understand that. The space is just limited on the field data sheet, so we kind of hope folks will utilize that additional notes and observations section at the bottom to kind of add any more explanation that is needed. So that's it for, I think, the field data sheet. So I'll be jumping over now to the memo that was developed by the North Coast Regional Board and provided to the benthic subcommittee. So next slide, please. Yeah, so this, what we're calling the thresholds memo, was developed by the North Coast region. It summarizes data from 2 pilot studies that were conducted in 2022 and 23. And basically, we were evaluating and implementing the tiered monitoring approach that Region 1 has been promoting, which is deploying your SPATs to kind of document increasing cyanotoxin trends. Then once you see those increasing trends, that would trigger visual assessments. So you get out there and see if a benthic bloom is present. And then if you do see a benthic bloom out there, you would then collect your benthic mat sample to confirm toxicity. And basically the memo evaluates that relationship between the 3 data types, so SPAT, cyanotoxin concentrations, with concurrent benthic mat coverage estimates and concurrent antitoxin concentrations in mats. And so we're looking at those 3 trends and really pinpointing where public health risks are apparent, both based on the data as well as, field observations. So ultimately, we do recommend a SPAT and benthic mat percent cover threshold based on this memo. So next slide, please. Just going into the comments that we received. So for clarification, just the overall document, is this a CCHAB product? Is it a benthic or a North Coast Water Board product? It's very much a CCHAB product. It was just, developed by the North Coast Water Board based on our studies. So we made this more clear. Results, some clarification just on language, such as SPAT deployment length, reported dates, percent cover, concentrations, or when thresholds were exceeded. So we did revise some language accordingly to kind of streamline and clarify those. Reporting results, there were some comments to check values against those that were presented in the graphs, kind of add more figure descriptions, as well as more descriptions explaining the results in the text. So those were either corrected or added and revised accordingly. Next slide, please. Some other comments on thresholds, kind of broke it down into intended use of thresholds as well as the derivation. For intended use, there was a request to kind of summarize the memo with a brief section at the beginning of the document, as well as include a table. So we did that. There was a question about were these thresholds appropriate for just public health postings or regulatory purposes as well? We explicitly stated, this is for public health postings and not regulatory purposes. And then added some comments about whether this memo was appropriate for lakes and reservoirs, and just basically elaborated that the data we evaluated was specific to rivers and recommend additional studies for lentic systems. Regarding the derivation of thresholds, we got some questions about kind of different scenarios like low coverage and high toxicity versus high coverage and low toxicity. We got comments about, human health endpoints versus best professional judgment, the use of detection limits and rapid increases in cyanotoxins, and then potential variability and visual assessments. We responded to those each kind of individually by adding additional language into the text. Thresholds were derived based on, the studies in Northern California rivers. Best professional judgment and historical data are used a lot in this scenario or in this instance because there's an absence of human health assessments or endpoints, but we will review those when they do become available, and explain how each threshold is kind of based on that relationship among the three data types, like I described previously, and we do expect to see some variability based on the river system, etc. And public health, we clarified some language about risk as opposed, or like using potential exposure instead. Clarified our definition of deliverability, and then made sure to include that the posting of advisory signs is in fact a voluntary action and not a requirement. Next slide, please. And then lastly, we had some formatting comments. We did, like I mentioned earlier, create a summary section at the beginning that includes a table. We also did create a new conclusion section at the end. And then editorial, as you can see listed there, just some details like axis titles, reported values, a lot of the stuff pertaining to results, and yeah, so a lot of those red line edits were accepted, rejected, or clarified as needed. And I think that covers it for me. So I'll hand it over to Jamie.
Yeah, so I'm gonna kind of take you all through the last two sections. So with that, can we go to the next slide? We'll talk about the signage. So in our kind of release of the package for review, there was the reviews of the documents, and then we had a form to kind of look at potential revisions to signage. And so we essentially kind of held a vote between two options. So what we're showing here in this slide here is what we called option one, which is just the sign as a dual language sign with no other changes from the previous iteration that was developed in 2020. And if you go to the next slide, we then had an option two, which included a handful of really minor revisions, but just revisions based on feedback from using the option one sign essentially for the last couple of years. And so some of the key changes are highlighted in those with those red circles. So one of them being that we added a place for the whoever's doing the posting to actually indicate the date of posting on the sign. We also updated the images. We had some feedback that the images on the previous slide were not as helpful, or they were kind of all looked the same. So we added some different images, including an underwater image of spires, just to help kind of people to better understand the diversity of how the mats can appear. And then we added a QR code to facilitate kind of the access to websites either through the text or the use of a QR code. So if you go to the next slide. So through that form, I know we said we had 16 reviewers. We actually had 29 people engage with the actual signage selection process. So a few more than those that provided reviews on the like all the documents. And so the majority vote was for option two, with 69% of respondents. We had a small number of respondents select the option of neither of the presented options, and I'd like to give you some reasons why. So if you go to the next slide, the reasons kind of behind selecting neither option, and frankly, these were comments that folks added in some of their other depending on like what else they voted for, but these are the general comments overall that we're seeing kind of related to the signs. And those were kind of under those themes. It was related to updates to signage formatting, sign content, and then the website and QR code that's provided. So as far as updates to formatting, there were some suggestions around making adjustments to the banners. Many comments kind of were pointing to the alignment of some of the images and content things being a little weird, and that there was kind of just an overall lack of space on the sign. It's a very full sign with both languages presented. Sign content was some requests about universal symbology, pointing out, and this was a common one too, was the too many words or too much jargon in the current wording. But that was, again, this was a minor fraction of the overall number of folks that voted. A request to kind of provide information on what the actual exposure symptoms could be, beyond if you feel sick, call your doctor. And then also, the signs highlight what you should not be doing. And they wanted to have a place to communicate information regarding what are the permissible activities and potential timelines of the warnings. And lastly, with the website and QR code, that's where we received the bulk of our comments, was a lot of suggestions about maybe a different website or the content that should be on a website that's associated with the sign, as well as why we had the written out link and the QR code. At first, they go to two different places. And we have a couple of minor suggestions. So based on all of these comments, if you go to the next slide, we made a quick kind of mock-up of a revision where there's really no content changes on the words. We just kind of moved some things around and cut one of the images of the spires down to kind of make some more space to make the website information a little bit more apparent and obvious. And are proposing that the QR code and the written out link essentially go to the same place. The reason for that being that some people don't know how to use QR codes, or maybe they want to take a picture because they're in a place where they don't have internet service, and then they have to take a picture and then find another phone to get the QR code. So having like both ways to get to the website makes more sense. And so we're proposing we received the majority vote on option 2 with the updated photos and the date posting information. And there was a little bit of discussion on the comment on these minor updates kind of related to layout and having a little bit more space. We've kind of tried to respond to that in this version. And so we're would like to call this kind of version 2 with response to comments. And this is the one we are proposing to potentially go with, but we'll get to that in a moment. So if you go to the next slide. So the last product is a visual guide. So next slide. So this is the final kind of element. This is a little 2-pager on how to identify cyanobacteria. So this is meant to be an additional resource to go with the guidance to help support things like the coverage assessment. And so it's mainly meant to be, it's not necessarily an ultimately, fully comprehensive guide, but a really helpful, easy to use kind of 2-pager that somebody could print out and kind of take in the field with them. So next slide. So we received very minimal comments. Most people were very happy with that document. We only received like less than 10 comments on it. Honestly, I think we received like 5 comments. And so they were around, the comments were kind of around overall presentation and around the photos that we were showing. So related to overall presentation, they asked, it was around the color palette and the color and size of the text boxes. And so we made some modifications kind of in response to those by changing some of the color backgrounds and sizes of the text and the borders around things kind of according to those suggestions, which were all kind of centered around like making it easier to read. And for the photos, There was a lot of really helpful suggestions on, this photo, like maybe add a photo with the glove test. You have a lot of photos of filamentous algae, and one about kind of excluding plant-like photos. And so in response to that, we don't have the glove test on there still because it was pretty limited in space, and that's an image that is available in some other FHAB resources. We did kind of try to remove some of the duplicative images, and then on the plant-like photos, we kept those just because, again, people get really confused sometimes, like duckweed, for example. And so we added some additional clarifying caption to kind of help describe when it was a plant-like photo, and added white circles and arrows kind of throughout to point out really relevant features. So with that, next slide. So we want to give everybody a little bit of a chance to kind of to talk to us and ask questions. But just to kind of sum everything up, final thoughts and next steps. So what now? We just kind of showed you the gamut of products developed by the work group and the review process that we went through. So none of the 16 reviewers that reviewed the document suggested an outright reject. They all kind of gave us either major or minor comments. And so given that, what we propose as next steps is that we'd motion to kind of move towards adoption of these products. And what I mean by that is kind of move towards making these kind of a CCHAB product through this work group. And so we are motioning to kind of have that done via co-chair review of the two co-chairs. I'm a co-chair, but I would recuse myself as one of the authors of the documents. So it'd be Sarah and Karen would kind of look through the documents. They would look through our documentation of essentially our responses. We have a more detailed documentation of that than we presented here, but this was kind of a summary to make it transparent how we've responded to all the comments received. And so they could kind of go through, verify that we made those changes, and then kind of approve the document for adoption. And so according to our charter, if there's no objections to that plan, then we can do that. If there are objections, then we can kind of come up with a different way to move towards adoption. So I'll just pause really quick and see if there's anybody that feels that they're not happy with that approach, and would want, to do something different to kind of move towards kind of adopting those documents.
Hi, does this mean that there is or is not an opportunity to discuss one or two specific points that weren't addressed in the comments here?
Yeah, so if you have specific points that you maybe want to make sure that we address, we'd welcome that kind of right now. So if it didn't get covered in what we just presented, we can definitely have that discussion. So I'd be happy to kind of address that right now if you'd like.
Sure. One of my questions that didn't come up was that in the sampling protocol, it was suggested to use a 250 milliliter bottle. And the way that the pinch samples are being done would mean that the sample volume is not consistent in terms of the mat versus the water. And I'm curious if that was considered in the revisions, to essentially have a bottle where you have it half filled with mat sample, half filled with water, so that the samples are actually comparable if they're being analyzed in a per volume way, which many of the samples are being analyzed. So yeah, just curious if that was addressed or if there's an opportunity to think more deeply about that in the final.
Yeah, that's a great question. Marissa, would you like to kind of weigh in on that? You did most of the revisions on that document.
Yeah. Mike and I saw your comment. It also was also expanded a little bit more also on the volume of the sample container, if it could be smaller as well. We wanted to have a larger sample container because then you have a wider mouth in the bottle, so you can get your material in if you're doing the pinch and placing it into or dropping it into your container while you're in the field. So we're focused on, what bottle size actually allows for a wide mouth. So we kept with the 250 ml, but there is an option to go down to 80 milliliters, because that's like the approximate volume that most labs need for just toxin testing. So when we get into like the lab communication section, we do acknowledge, some of the points that you brought up with your comment that about the volume. And so one thing with the procedure that we're moving towards is standardizing how laboratories determine toxin concentration and what those resulting units should be. So historically, we all start off with planktonic bloom monitoring, and that results in amount of toxin per volume of water. But as we've reviewed much literature, research, and approaches with benthics, much of the community has moved towards determining amount of toxin per weight of benthic material, determining ash-free dry mass, and correlating that to weight. And that's something that also Chris Nietzsche presented on today, like how they looked at different ways of normalizing toxin concentration. And so as part of this process, the FAB program, being under the umbrella of SWAMP and major quality assurance development of procedures and lab processes, SWAMP is volunteering some of their time to develop a quality assurance document to help labs standardize the processing of the benthics. So then the resulting units would be about normalizing the toxin per weight. Sorry, that was like a long kind of story to get us to that. We weren't, sorry, not we, SWAMP wasn't prepared to share that along with the review cycle. It's something that is being developed separately along with several labs that are processing the majority of benthic samples in the country. So it's going to be something coming separate. So that's like what we've designed this for. So if folks do want to maintain a microgram per liter resulting units, making sure that you have uniform amount of volume of water in your sample container is an appropriate step, as you described. And that's in the laboratory communications section of the document.
Yeah, I mean, that sounds ideal if you can do it for dry weight. It would be really interesting to find out. I mean, it sounds like you guys are working with like potentially the EPA lab and other common labs that are doing this in California. I think it would be really great to revise the methodology to reflect an equal amount of water and mat material. If somebody does end up doing a volumetric rather than per mass, because I think as it's written right now, there could be a lot of variation in the amount of mat material to the water.
Yes, there will be a variation about with the mat material if like the mat material is really thin and not like dense vertically. Your pinches may be a little bit different, weight or density. That's right.
Right, which I guess that was another point that's super related then, is then rather than having like exactly 12 or 6 pinches, to be able to have variation in the number of pinches throughout the reach to make sure that you get enough mat material, that you have an equal part mat material and equal water in your jar.
So we considered that comment as well about having more flexibility of the number of pinches or pieces, right? So that each pinch represents about 3 square centimeters or about a quarter coin. We did consider that, but we wanted to stay with a standardized approach. So everyone's targeting the same approximate amount of mat material. So it's still for the combination of in water and shoreline, that option either in the channel or lake, you're taking 12 pinches. And then if you're using the option of no water waiting, waiting in the water, then it would be 6 pinches. So yeah, again, there's that difference again that's introduced based off of the options in the procedure as well. And we recognize that.
Right. But that would produce a dramatically different amount of mat material depending on the mat thickness.
That's right. And so the field data sheet and, submission of your results, that comes together, and then there's a description on how best to interpret that as well. And so the last step of the procedure is reporting and to, share it with the implementing agencies of the CCHAB network guidance to get support on interpretation. So, the first time you're doing this different option, then you can then learn, kind of how to roll it out. And then, that's kind of like part of a commitment to training and coaching that implementing agencies of the CCHAB products have. Any other clarifications, Laurel?
Sorry, thanks for that. I think the one other question I had, and this was presented early on, was that the use of qPCR was not considered. And I'm curious about that, given that it is a much more affordable process and that there's some good data showing really high correlations between qPCR and ELISA toxin methods.
Yeah, so you're referring to using qPCR methods in the lab to target the toxin genes that are documented to, express and produce the toxins from cyanobacteria, right? So toxin gene targets, not taxonomy. Okay.
Yeah, exactly. Sorry, the
Sorry.
qPCR methods.
There's two realms in like eDNA. It's folks use qPCR methods for taxonomy or for toxin genes.
Count of potentially toxin producing cells in a sample.
Okay. Yeah, so we're aware of like that research, and there's more and more information, coming out to better develop those correlations. Just at the onset of our reinvigorated, subcommittee, the literature review and data that we were able to review at that time, that there, for toxin concentrations, there aren't human health targets, for drinking or eating the material. So that's why we went with like a trigger for advisory postings based off of percent coverage. And then based off of research that we saw and also the North Coast region did in California, looking at toxins in the mats and in spats help provide context. The environmental conditions and your community of cyanobacteria and potential risks to characterize your area. And those were like the kind of like more prominent indicators that came out of that literature review. And so that's why the guidance speaks more to those. But, one can reasonably expect that in the future, when the subcommittees reconvened, if necessary, if we don't have governmental regulations, then perhaps there would be more strong correlations with the toxin genes. Yeah, it's something that we look at actually in the FF program at the water boards. In planktonics, something that we're hoping to do more statistical analysis to develop correlations using toxin genes, because it is so much cheaper than toxin testing. It's something that we've been looking at for a number of years, and hopefully we can move towards that also in benthics.
Great. Yeah. And if they're willing to share it, I think folks at Ben Genetics has a lot of really great data showing.
Yeah, I agree. Yeah. Ben Genetics is our primary partner at the FF program, and our research into toxin genes and qPCR. Really grateful to be able to work with them so closely.
Great. Okay, so Laura, if you feel that addresses your comments and you feel comfortable with kind of moving forward, then we can kind of move forward with the adoption process that I just described that kind of involves the co-chair. If you have discomfort though, we can kind of come up with an alternate approach where there's a chance for review. We wouldn't necessarily be soliciting a full set of comments, but it would be, we could kind of facilitate a review of some sort of the updated documents if there's still discomfort, if you don't feel that we've addressed your questions right now.
I just wanted to point those things out. I mean, I think it would definitely be stronger if there was an expectation for, you know, equal mat and water in terms of comparison. But if I'm the only one who has that strong feeling in this, I'm not, you know, I'm totally fine to default. I do think it would make it stronger if there's other folks in your guys' final discussion that want to consider that. But I'll leave it as a recommendation and by no means a, you know, requirement.
Great. We can definitely consider that. Maybe there's a place we can even have a couple of recommendations for future research or something. We can probably even address that qPCR point that you have as well. So are there any other, I know we're butting up right on time here, but is there any other questions or objections to kind of moving to co-chairs for adoption? No objections? Okay. I'm not hearing any, and there's a couple people in the chat that have indicated no objection. So with that, we'll go ahead and move forward with getting the products to co-chair. It'll take us, like Marissa mentioned, we're going to put it through a professional copy editor for like grammar and that sort of thing before we get it to the co-chairs. So after co-chairs review, verify that we've made and responded appropriately to all the comments, which we've tracked kind of row by row. We will then put the document through ADA compliance. So there may be some small additional changes for formatting as a result of that kind of compliance formatting, and then we would post it online. So thank you everybody for the attention and questions and so many thoughtful and careful comments from so many of you. We really appreciate the time that you put into reviewing the document. I know it was a lot to read, and it was over the holidays. So we really appreciate that, and we're excited that it can be out and ready to go for the 2025 kind of bloom season as it gets rolling. So with that, I know we're 2 minutes over time. So unless there's any kind of final thoughts or anything related to this or the CCHAB in general, we'll kind of move to conclude today's meeting. I'm happy to take any questions, you know, if they come to you at 3 o'clock in the morning tonight. Please reach out. You can either reach out to the Benthic Habs team directly or to the co-chairs and we all talk to each other all the time. But with that, thank you everybody for your time, and I hope that you enjoyed this meeting. Our next meeting is on April 9th for the spring CCHABS meeting. So with that, see you in the spring.